Ever opened a YouTube video to learn how to build an AI SaaS app, only to find out you need a credit card, a dozen different API keys, and 5 different subscriptions just to access a couple of models? You know exactly how it goes. They tell you it's simple, but then you're setting up S3 for storage, a dedicated database for metadata, and a separate backend server just to keep the lights on. By the time you're done, you're a customer of 5 different companies instead of an engineer of your own product. What if you could skip all that and build a production grade AI application with instant access to powerful models from Claude to Gemini without a single external subscription, no credit card on file, and zero API key management? Sounds unreal, but it's happening. Hi there, I'm Adrian, and welcome to the only course on the internet that skips the infrastructure tax and teaches you how to engineer an AI SaaS app from the ground up. Today, you're building Roomify, an AI-powered architectural visualization platform that transforms flat 2D floor plans into photorealistic top-down 3D renders. An app so good that I almost decided to deploy it and actually sell a subscription for it myself. But I'll leave that up to you. Here's what you'll build. Instant 2D to 3D visualization that turns architectural sketches into photorealistic renders in seconds. Persistent media hosting that generates permanent public URLs for every upload and output. A dynamic project gallery that tracks your personal history of visualizations with instant loading. Side-by-side comparison tools to visualize the transformation from source image to the AI render. A global community feed where users share projects with the world in a single click. Public and private toggles, giving users full controls over the visibility of their architectural data. Clean ownership mapping that tracks project metadata and user IDs across the entire system. And the modern export functionality to take your AI-generated renders and move them into the real world. By developing this, you'll learn how to architect a shareable SaaS platform that feels instantaneous to the end user without having to pay anything. To make this happen, you're using cutting-edge tech stack designed for 2026. React plus Vite for a clean, bold interface that handles complex image states. Tailwind CSS for rapid, responsive styling. And Puter for serverless workers, AI rendering, permanent file hosting, and key value storage with no credit card required and zero cost to you forever to use the most powerful AI thanks to their user pays model. More on that soon. I'll also teach you how to use CodeRabbit for AI-powered code reviews that ensure that your project is architected for the long term. Oh, and since AI is here, and you just gotta learn how to use it, I'll also teach you JetBrains' Junie, the AI copilot to help you write complex worker logic and prompt engineer side by side. You'll do all of that while implementing industry standard practices and clean code that would usually take a full DevOps team months to figure out. By the end of this video, you won't just know how to build an app, you'll know how to engineer a SaaS that is lightweight, instant, and completely self-contained. If you're serious about leveling up from watching tutorials to actually becoming hire ready, you'll love JS Mastery Pro. It's where I go beyond the build this app stuff and teach the engineering mindset behind the code. Inside Pro, you get full premium courses like the Ultimate Next.js, testing, animations, JavaScript, SQL, 3JS, and more. Quizzes after every lesson, so you actually lock in what you learn. Interview practice with our AI interviewer, so you can train for real technical interviews the same way you train for a sport. And we're also launching the Ultimate Backend course and our AI engineering courses next, and our Pro members get early access. You also get access to our private Discord where you can ask questions to real human beings and get help fast. If you want to check it out, I might give you a special discount just because you're coming from this video. Give it a shot. The link is in the description. And finally, are you ready to build the future of AI architecture? Go grab your coffee and let's ship this. To get started developing Roomify, we first have to set up our project. And that's going to be easy because we'll be using React. Specifically, we'll spin up a simple React application using Vite. And would you look at that? It looks like they have a newly designed landing page, which is looking very fresh. We can copy the installation command directly from here, and then you can open up your text editor or IDE. In this case, I'll be using WebStorm. I decided to use it as of recently, it became completely free for non-commercial use. It used to be this expensive yet super powerful IDE that now you can develop on as well. And of course, it comes with a lot of powerful AI features, specifically Junie, the coding agent created by JetBrains that I'll show you how you can use throughout this course to improve your productivity. You know that knowing how to code with AI is no longer something you can ignore. So while I'll code everything by hand in this course, there's going to be a couple of situations where I'm going to teach you how you can also speed up that manual workflow with the help of AI. So go ahead and download WebStorm and Junie in case you want to follow along and see exactly what I'm seeing. I'll create a new project. It's going to be an empty project on my desktop, and I'll call it Roomify. Once you open it up, you can also open up the integrated terminal within it, and there we can paste the Vite command we just copied, but I'm going to add a / at the end so the application gets created in the current repository. It's going to ask us whether you want to install the Create Vite installer, to which I'll say, why? Please proceed. It's going to say it's not empty. That's totally fine. We can remove everything that's within it and then continue. And of course, we'll build with React. And for the variant, I'll actually go down and we'll use React Router v7. So select that and press enter. And we can also use the upcoming version of Vite. I also installed the Create React Router, and we don't have to initialize a new Git repo right now because we'll do it together very soon. You can then install all the dependencies so we can spin up this project. Now, while our app is getting set up, you can head over to Puter.com and click Get Started. Then if you go to the top and click right here, you'll be able to create your account. So go with something you like, enter your email address and a password, and then create your account. Once you create it, that's it. You're logged in. But what exactly is happening here and why are we inside of a virtual desktop? Well, we'll use Puter to handle all the backend AI for this project. And I've decided to teach you how to use it because it's different from everything I've used so far. First, it's completely free to get started with. As you saw, it required no credit card and there's no trial period that expires. You can also head over to Puter.js docs, which tells you a bit more about it. It essentially brings free, serverless, cloud, and AI directly to your frontend with no backend code or API keys required. You just have to install their npm module, drop a script, and you get access to everything. But how is that really possible? It's explained within their user pays model page. That means that your users cover their own cloud and AI usage. Instead of you, as a developer, paying for servers and APIs, like S3 for storage, Vercel for hosting, Supabase for databases, and OpenAI for AI, well, Puter gives you serverless workers for compute, key value storage for data, permanent file hosting, and the use of AI. So whether you have 1 or 1 million users, you pay nothing for the infrastructure to run your application. I found this model super interesting, so I decided to make the video teaching you how to build on top of it. And it's completely open source. So if you head over to their GitHub repo, they have almost 40,000 stars. So let's help them a bit in reaching it. You can see that it is actively maintained and updated. So by the end of this course, you'll see exactly why this matters. Because you'll ship a production-grade AI SaaS application without touching a single config file or entering a single credit card number. You can read more about it here. Once the installation is complete, you can run npm run dev. This will spin it up on localhost 5173, where you can see the default React Router landing page. React Router v7 is quite new, so you can also go to its docs, and here I'll show you how we can implement routing using it. We'll do that very soon together. But before that, let's go over the file and folder structure of the application so everything is 100% clear to you. Let's start with a package.json, which defines the project names, the type set to module, so we can use import statements, and some scripts needed to run our application, as well as the dependencies that are going to run with it. There's a package log.json. To fix those, it works on my machine problems by making sure that whoever installs this application matches the exact dependency versions. There's the tsconfig.json. This file mostly exists to make sure that TypeScript behaves correctly with full stack React router and the Vite setup. There's also the Vite config for that same reason, and it allows us to run different plugins such as Tailwind and React router itself. The Docker file allows us to create a reproducible deployment path. Basically allows us to create a container so that we can ship the application and run it elsewhere. There's also a README that you can go through, which for now just contains the info about this Vite application and React router docs. But of course, things get interesting within the app folder, specifically within the root.tsx. We start with some links, and there's the layout. We set the HTML, the head, and the body of the application, and we bring in the links and meta, which are the helpers coming from React router. But more importantly, we can head over into routes.ts. This file exists because React router's framework mode expects a central routing config, and it all starts with the home.tsx. So let's visit it. It's going to be within routes home.tsx, where we have some metadata, and then we have a component called welcome, which is one of the first components that we have right here. This component simply rendered what you saw when I spun up the application on localhost 5173. There's also the app.css, where we're importing Tailwind and some fonts. Let's start by completely deleting the welcome folder and heading over to routes home and displaying a simple text instead. So I'll render an h1 that'll have a class name of text-3xl, text-indigo of 700, and font-extra bold, a couple of classes just to make sure that Tailwind works. So now if you remove this import for the welcome component and just render this h1 and go back, you should be able to see a piece of text that says home. That's it. It means that everything is set up from Tailwind to React routes within a single command using Vite. And that means that we can run into the first component of our application, which is going to be the navbar. To get started with the navbar of this application, we can put the browser side by side with our editor. I'll keep it to this width so we can still see all the links, and then open up WebStorm on the left. Create a new folder called components. It's going to be outside of the app folder. And within components, create a new file called navbar.tsx, inside of which you can run rafce to quickly spin up a new navbar component. Then you can simply import it within your homepage. So head over to app, routes, home, and right here we have the h1. We can wrap that h1 inside of a div. So I'll make this a multi-line return and have the div right here. This div will have a class name set to home, and then right within it, we can render a self-closing navbar component, which we can import from components navbar. So if you head over to your localhost 5173, you'll be able to see the navbar at the top. Now we can open up a new terminal. I'll leave this one running, which is going to be running the app, and the second one I'll simply call terminal, within which we can run npm install lucid react, which is going to install some icons. Then for the styling of this application, we want to get it to match as close as possible to this final beautiful design. So let me share with you the design, which you can get by heading over to the video kit link down in the description, and then finding the app.css. Then you can remove everything you have here, copy the one over in the video kit, and simply paste it here. You'll notice that we'll add some theme colors, as well as the base resets on the design, and then most importantly, some component styles, so that we don't have to spend time building the button. We already know how it'll look like. Same thing for building different cards, navbar, auth modal, and so on. But of course, if at any point you're interested in how this CSS looks like, you can just go ahead and refer to it within this app.css file. But let's be honest, I don't think we'll ever be interested in how this CSS looks like because, if I'm being honest, this whole UI was generated by Gemini's AI Studio. So more and more, those UIs are going to get built by different AI tools, and it's going to be up to us to not style them, but orchestrate those AI agents to develop great software that we can then ship. Don't worry, because I'll teach you how to do that throughout this course. So now let's head over into this Navbar component and let's implement it. We can start pretty simple by turning this into an HTML5 header component with a class of Navbar. And then you can, of course, open up the current version of the application to see it here. Within the navbar, I'll create a new nav with a class name of inner, and then within it, a new div that'll have a class name set to left, within which we can have another div with a class name set to brand, within which we can display a box, which is going to be coming from Lucid React, and it'll have a class name set to logo, and then we'll also render a span element with a class name set to name, and this is going to be the name of our application called Roomify. Now, below this div, keeping track of the span, we can create a UL, an unordered list, that'll have a class name of links, and within it, we can display an anchor tag that has an href set to just empty, like this. Later on, we can add them if needed. But for now, I'll make the first one say product, the second one pricing, the third one community, and the fourth one enterprise. These are the links that typically the landing pages of great AI SaaS tools have. So later on, we can extend this to have either a multi-page landing page or to have a single page landing page that'll have these different sections within it. Then we can head below this div and create another div that has a class name set to actions, and within it, a button set to on click. Here we want to authenticate the users. So I'll call the handle auth click. This is a function that we'll implement very soon, but for now, it'll stay as an asynchronous callback function, which is going to be empty, waiting for us to implement its logic. It'll also have a class name set to login, and within it, we'll make it say log in. You can see it now on the right side. Finally, below this button, I'll render an anchor tag with an href of hash upload with a class name of CTA, call to action. This is going to be the most important button, so we want to make it a bit pronounced, like this. Get started with turning your boring floor plans into interiors that actually make sense. And since we'll be using buttons a couple of times throughout this application, it makes sense to create a reusable button component. You know how when you use ShatCN, there's components, and then there's a new folder within it called UI, and then there, typically, you have a component as simple such as a button.tsx. Since we're not using ShatCN here, I want to teach you how you would approach building a component as simple as a button that has to be extensible. Or in this case, I want to teach you how you can use AI to create it for you. So simply press Command-Shift-B and search for Juni. If you haven't yet done that, go ahead and install it for your IDE or text editor, and we can tell it what to do. This is going to be the first task that we're going to give it. And recently, I started tweeting more of where AI is going to go. I said that I built an entire application without writing a single line of code manually, but I couldn't have done it without 8 years of knowing how to code. So AI isn't going to replace your skills, it's going to give them leverage. But you still have to know how to code, and that's exactly what you're getting from these videos. But then again, AI will soon write more than 80% of your code. But that doesn't mean you matter less. It means understanding, judgment, and architecture matter more than ever. I'm not talking about vibe coding, I'm talking about the next era of development. And since this is a skill that I believe you need to have moving forward, I started working on the Ultimate AI Development course. Right now, there's only a waitlist, which I'll leave linked down in the description so you can join, but I'll be dropping the first lessons very soon, so make sure to sign up to stay up to date. With that said, let me give you a bit of a preview of how I would approach creating something as simple as a reusable button with the help of AI. I'll tell it to create a React TypeScript button with props for variant, size, whether it's a full width or not, and class name, and we'll tell it to use the BEM style classes similar to what ShadCN does, like btn dash dash variant and btn dash dash size. Default these to primary and medium, then return a button spreading all props with the combined classes and children. And let's see how it does. And very quickly, Junie will come up with a plan, understand the structure of your application, open up the file that it needs to edit, and then implement a new button component. This was a super simple task, so the prompt was simple as well. Now, let's use this button component within the Navbar. You can head over into Components, Navbar, and let's also create two new variables. One is going to be called isSignedIn, which for now I'll just default to false, and the other one is going to be our username, which you can set to your name. In this case, I'll just leave it as Adrian. Once you create those, you can head over below links and into actions, where right now we have just a single login button, but instead we want to wrap it with the check to see whether we're signed in or not. So if we're not signed in, then we're going to render this login button, but we're going to wrap it in an empty React fragment so we can put something else next to it as well. In this case, we can just bring back this anchor tag right next to it that's going to say upload and get started. Now, if we're not signed in, we can render again an empty React fragment and within it a span element that'll have a class name set to greeting that's going to render the username. If it exists, then we'll say something along the lines of hi, username, else we'll say signed in if we don't have access to the username. And then we can render this new button component we created that'll have a size set to small, and on click, it'll render the handle auth click with a class name set to btn. And this one will say log out. We can also modify this button to use our own button component. And instead of the class name of login, I'll provide it a size of sm and a variant of ghost. So now if you head back, you'll be able to see login and get started. But if I change the isSignedIn to true, you'll be able to see hi Adrian and log out. Perfect. This will work as soon as we implement the authentication functionalities, which is going to be our next step. To implement authentication and to make this part functional, we can install Puter.js, because one of the things that it offers are authentication functionalities. So we'll very easily be able to sign in the user. To do it, we first have to install Puter. So copy the installation command, open up the terminal, and type npm install @heyputer/puter.js. It's super lightweight, so it should install quickly. And then create a new file, or first we can create a new folder at the root of our application called lib. And within lib, you can create a new file called puter.action.ts, inside of which we'll implement all the actions provided to us by Puter. In this case, the actions for sign in, sign up, or sign out. The only thing you have to do to make it happen is say export const sign in is equal to async function that awaits the action and then calls Puter, coming from the package we just installed, .auth.sign in. It cannot be any simpler. Then we can do the same thing for sign out by using the sign out functionality. And finally, we'll also create a helper function to get the current user. So export const get current user is equal to an asynchronous function where we can open up a try and catch block. In the catch, we can simply, for now, return null. And in the try, we'll return await puter.auth.getUser, which is a method that allows us to, well, get the current user. And sign out is not an asynchronous function, so it doesn't need an await in front of it. I think that's why our IDE was complaining. Now we can integrate this Puter auth within our app root. That's going to be right here. We'll do it by using React Router's use outlet context. This returns the parent route, and often parent routes manage state or other values you want shared with your children. So in this case, this is like creating a context provider, but in this case, it's built into the outlet. So what you have to do is head right here below the layout, but above the app, and we'll create a new default auth state. So we don't have to recreate it every now and then, which is going to be of a type auth state. I'll tell you a bit more about this very soon. But for now, you can just declare this as an object that has the is signed in value by default set to false, the user name set to null, as well as the user ID set to null as well. Now, for this auth state, we have to create a new type. That way, we're telling TypeScript to know exactly the kind of data that we'll have within this object. So to do it, create a new file right in the root of your application called type.d.ts. This stands for the definition of all the types. And here we can create an interface of auth state. And there we can define the same things we had, is signed in of a type Boolean, user name of a type either string or null, and then finally the user ID of a type string or null. We can also define a type for the auth context. To know what we're going to keep within there, we're going to keep all three of these variables, is signed in, username, and user ID, as well as refresh auth, which is going to be of a type function that results in a promise that finally returns a Boolean, as well as a sign in and sign out functions, which are going to be of the same type. So we can do something like this. Perfect. Now back within the root.tsx, you can see that auth state is now recognized and it knows exactly the type of the default auth state. This is going to be useful later on. Now within our application where we have this outlet, we can define this state, which means that we're sharing it within every page of our application. So that's going to be auth state, set auth state at the start equal to the default state of a type auth state. I think I might have said auth state one too many times. And then we can define this function for refreshing the auth, which is going to be equal to an asynchronous function where we can open up a try and catch block. And in the catch, we can simply set auth state back to the default auth state and return false. But in the try, we can try to get access to the current user by saying await get current user, which we can use directly from the Puter action we created called get current user. Or what you could have done is simply said await Puter auth get user here. But since we're going to use it a couple more times, it's nice to create a reusable call. Then once we get the user, we can set the auth state and fill it in with real values. Is signed in is going to be double negative of the user, which means that if we have the user, it'll be set to true. Username will be set to user !username or null. And then finally, user ID is going to be set to user.uuid or set to null, like this. And you'll see that the set auth state will not complain because this matches its type. And finally, we can return ! user, which is going to basically say true if a user exists. Now that we have this refresh auth function, we can use it somewhere, and we're going to use it within a simple use effect. As soon as we load the app, simply refresh the auth so we get access to the most recent user. And that's the only thing that this use effect is going to do. So we can continue going over by creating a new function called sign-in, which is going to be an asynchronous function. And here we're going to simply use the server action we created before by saying await sign in, and then return await refresh auth. So as soon as we create an account, we can refresh it so that the changes get recognized. And we can do the same thing for sign out. So as soon as somebody signs out, we can then refresh the auth and let them know that they're signed out. So I'll rename this to sign out. But notice that now we have double names, sign in here, and sign out here, both created by us in this file and also coming from this file right here. So I will rename these sign in as Puter sign in, and sign out as Puter sign out. That way, there's not going to be any confusion. We're awaiting Puter sign in, and right below, we're awaiting Puter sign out. Perfect. Now that we have created these functions, we can actually share them among the context of our application. That's going to be right here within the outlet. But first, we'll actually return a main. So we're wrapping this entire application with a main that's going to have some classes, such as a class name set to min-h-screen, so we can manage the height of the screen properly, bg background, text-foreground, and relative, as well as z10. And then we are rendering this outlet to which we can now provide this additional context. New React Router made it super simple to provide this context to all of the inner pages. So we'll first spread the auth state, then I'll pass the refresh auth, the sign in, and sign out, so we can now use these functions from whichever page we want, which therefore allows us to implement the auth functionality within the navbar. Remember, that's exactly where we were. For now, this functionality right here is fake, is signed in and username. These don't really exist as real variables, just fake ones. So instead, say const, and these structure some data coming from use outlet context, coming from React Router, and it's going to be of a type auth context, so we know what this is all about. And we can extract things like is signed in, username, sign in function, and sign out functions. I think we'll have to rename our username here. Now it starts with a capital N right here. And besides that, we'll have to make this handle auth click work by checking if we're currently signed in. So if is signed in that case, I'll open up a new try and catch block. In the catch, if there's an error, we'll simply console.error, something like Puter sign out failed, and then we'll display the error, and then we will return. But here we can try to successfully sign the user out by using the sign out function we created coming from Puter. But if we are not signed in that case, we can open up a new try and catch block. In this case, we can console.error, Puter sign in failed, and we display the error, or here we can simply try to sign the user in. Again, make sure to have this return right here because that actually exits this function if the user is signed in which case this executes, else the sign in logic executes. And with that, believe it or not, we can already test the auth functionality. So if you head over here, you'll see Hi JS Mastery. I think this is because I logged into the Puter computer, that's Puter.com before. So I'm already logged in. And now I can log out and you can see that that's it. We are successfully logged out. Or you can click login, which redirects you back to Puter.com where you can choose which account you want to log in with. And that's it, you're back. Puter handles the users, but also the users' spendings for us, so we don't have to worry about managing their tokens or whatever they're doing within our application. That'll make it even easier for us later on to develop the core functionalities of our application, which is to upload a floor plan and allow them to create a beautiful architectural floor plan. We'll get there soon. But now that the start of our application has been implemented, with the initial route being home, the initial component, as well as the initial logic, which is all about authentication, we are ready to actually test it out and see if that logic is fully bug-free and whether the code is scalable. Oh, and we already developed a lot of stuff, so it's a good idea to push the code over to GitHub. So open up your terminal and run git init. Then head over to github.com/new and create your new application. This is going to be Roomify. Just click Create Repo, and then you'll be able to copy some of the commands to quickly spin it up. After git init, we can do git commit -m first commit. Oh, but first we have to run git add dot to track all the files. Git branch m main git commit, first commit, git remote add origin to connect the local one to the public GitHub repo, and git push u origin main, which will push all the code we have so far directly within our GitHub repo. So now that the base of our project has been created, for every other major upcoming feature in this course, we'll use CodeRabbit to review it, because we want to move fast but don't want to break things. CodeRabbit is the leader in AI code reviews with over 2 million repos reviewed and many more millions of defects found. So I definitely want to teach you how to use it. Click the CodeRabbit link down in the description and try it for free. You can create an account using GitHub and it'll load your workspace. Once you're in, you should be able to find your repo. That's going to be Roomify. This is only going to work if you've given CodeRabbit permissions to access it before. So click Add Repos, sign into your GitHub account, and you can give it access to all or only some of the repositories. Then you should be able to find it here, and whenever we add some new features, we'll open up a pull request to check whether our code is looking good. So in the next lesson, we'll develop this entire homepage, and then we'll be able to test it out. And only if that's working, we'll be able to move into uploading our floor plans, which forms the baseline of our app's functionality. So I'm super excited to build it with you. To get started developing the UI of our homepage, you can head over into App, Routes, Home. This is where it's going to live. So right within here, we have our div with a class name of home, and then at the top, we have the navbar. But instead of this H1, let's now render a full-on section that's going to be used for the hero section. And instead of taking a look at the final product, let's actually open up our current one, which is completely empty, and add something within it. I'll add a div with a class name set to announce, and then within it, another div with a class name set to dot, and then a div with a class name set to pulse, and it's going to be just a self-closing div with a pulsating dot. Then below this div wrapping it, we're going to do a p tag that's going to say introducing Roomify 2.0. We're not yet done with version 1.0, but hey, you got to keep people excited. And then right below this div wrapping all of that, we'll render an H1 saying build beautiful spaces at the speed of thought with Roomify, like this. And then we can also add a subtitle right below it with a p tag of class name set to subtitle. And we can say Roomify is an AI-first design environment that helps you visualize, render, and ship architectural projects faster than ever. And looks like WebStorm nicely caught this little issue, environment. Perfect. So now we have the headline and the subtitle. Let's also add the primary calls to action by creating a div with a class name set to actions. And within actions, we can display an anchor tag that's going to have an href pointing to hash upload and a class name set to CTA, similar to the one we created before. And it'll say start building alongside the arrow right coming from Lucid React. That's going to have a class name set to icon. There we go, start building. Then below this anchor tag, we can also display a button. This button is going to be our own reusable button component. It's going to say watch demo, and it'll render with a variant of outline, a size of LG for large, and a class name set to demo. There we go. So now we have start building and watch demo. Now below it, we can also display the upload div. So I'll head below this div containing the buttons and the actions, and we'll render a div with an ID of upload. That's going to have a class name of upload dash shell. So now you can get the idea of where we're going with this. But let's make it a bit more obvious for the users what this upload div is all about by creating another self-closing div within it that's going to have a class name set to grid overlay. And then below it, another div that'll have a class name set to upload dash card, within which we'll have another div with a class name set to upload dash head, like this. And within upload head, we'll render an upload icon by giving it a class name of upload dash icon. And within it, we'll render a layers. This is coming from Lucid React with a class name set to icon. There we go. And now we just have to explain what this is with words by adding an H3 saying upload your floor plan, and then a p tag that's going to say supports JPEG, PNG formats up to 10 megabytes. There we go. Now this is super clear. And below this div, let's also add a p tag that says upload images. And later on, we'll make this functional. And we also have to display the projects that other people have uploaded. And we'll do that below the current section. So this section right here is just the hero section, which we can now collapse. And then we'll create a new section for projects. So I'll give it a class name set to projects. Then within it, I'll render a div. And this div will have a class name of section-inner, within which we'll have a div with a class name of section-head. And within it, we'll render a div with a class name of copy, because this will include our actual copy, such as an H2 that'll say projects. And then below it, a p tag that'll say your latest work and shared community projects all in one place. So now if you scroll down, you can see this section for the projects. Of course, in this case, we'll also have to display the projects grid. So go below this P and two more divs down and render a div with a class name set to projects-grid. And for now within it, we can render a div with a class name set to project-card and group. And then within this card, we can render a div with a class name set to preview. That's going to look something like this. Within this preview, we can render some kind of a demo image. So type image and then give it a source. I'll provide you with this preview image source link in the video kit link down in the description, just so you don't have to manually copy and paste it. But basically, it's going to be a URL pointing to an image that looks something like this. Maybe I even find a better one, so for you, it might look a bit different. And I'll also give it an alt tag set to project. This is an example of a finished interior design floor plan. Then let's head down and let's also render a div with a class name set to badge and a span that says community. So we can know whether we have created this project or maybe it was created by the community, by somebody else. We can then head these two divs down and create a card body by giving it the same class name and then a div within it. And then we can render an H3 that's going to say something like project, and you can give it any kind of a name, like I'll do Manhattan. You can see that right here. And then right below this H3, you can render a div that'll have a class name of meta, as in metadata about the project. So it can consist of a clock icon with a size of 12, and below it, a span element that'll render a new date. And here you can put any kind of a date. Let's do January 1st of 2027, and then .to locale date string, which is going to nicely display it in this format. Below this span, you can render another span that'll simply say by JSM or JS Mastery. So basically telling you who created this project. Finally, we can go two divs down and render another div with a class name set to arrow. And we can render the arrow up right icon coming from Lucid Icons React with a size of 18. So now when you hover over it, it appears as the entire card is clickable. Of course, I'm super zoomed in right now, but if I go back to 100% the size, you'll see that this looks good even on half the width right here. Or if I increase it a bit, you'll see that it's going to look even better. Below our upload, where we can upload our own floor plans, you can explore community plans, which later on will lead to their dedicated pages. And this is cool already. Sure, we got some pretty UI, but I think what you're interested more about is how we can actually implement the AI that does what I've showed you in the intro, that takes a basic, boring 2D floor plan and turns it into something that looks like this. So let's do that next. But since that's going to be a big feature, we can push the current changes that we have so far by running git add dot, git commit -m, implement homepage UI, and git push. But now for the next section, we want to actually create a new branch out of it to be able to develop it properly on a separate branch so we can review it and then merge it back to the home branch if it's properly implemented. To do that, you can run git checkout -b and you can call the branch upload files, because that's exactly what we're going to do in the next lesson. So it will have automatically switched to that branch and we are ready to get started implementing it. To start working on the upload component, let's create it by heading over into the components folder and then creating a new component called upload.tsx. Within it, you can just run rafce to quickly spin it up, and then you can import it within the home route right here where we had a piece of text that says upload. So that's in the hero section. At the bottom where it says upload images, simply replace this p tag with the call of the upload component coming from components upload. And if you do that properly, nothing should change because this component just says upload. And if you write test, you'll be able to see upload test right here, which means that we can start developing the inside of this upload component. Now we can start with the JSX part first by giving it a class name set to upload. Then we have to check whether we have a file within it or we don't yet have an uploaded file. And for that, we can create a new variable at the top. It's actually going to be a state field that we can keep track of. So I'll create a new use state snippet and call it file, set file, and at the start set to null. And this will be of a type either file or null at the start. Then we can also create a couple of other state snippets, such as is dragging to know whether we're currently dragging a file in, which is going to be set to false at the start. And we can also have another one called progress and set progress at the start set to 0, which is going to keep track of the upload loader. Alongside this, we also need to know whether the user is logged in. So I will get access to the is signed in variable, which is coming from use outlet context of a type auth context, and we can get it like that. Now, right within the upload, we can check if there is no file right now. In that case, we can render a div, and this div will say something like no file. Else, if there is a file, we can render something else, and in this case, I will simply say file, because there is a file. Right now, there's no file, and I'll make this a bit bigger so you can see it. There we go. So if there is no file, we have to somehow show the users that they can drag and drop it in. And this has to be within a div like this. So let's give this div, if there is no file, a class name. It's going to be a dynamic class name of drop zone. And if we're currently dragging, then we'll give it a class of is dragging, else we'll leave it empty. So now we can see no file. And if you hover or drag, you can see that something is happening. Then within this div, let's render an input that's going to have a type set to file. It'll have a class name set to drop-input. It'll also have an accept property, and it's going to accept a .jpeg like this, and .png, as well as it'll have a disabled state if we're not signed in. In that case, we can just disable it. Let's add all of these to their new lines like this. And let's see why this accept is complaining. Oh, I was missing an equal sign. There we go. And now below this input, we can render a div with a class name of drop-content and a div with a class name of drop-icon so people know they can actually drop something in, and it'll be the upload icon coming from Lucid Icons with a size of 20. There we go. That makes a bit more sense. And below this div, we'll also render a p tag that'll check whether we are signed in. And if we are signed in, then we'll say click to upload or just drag and drop. And if we are not currently signed in that case, we can say something along the lines of sign in or sign up with Puter to upload. There we go. That's pretty clear. I'm going to zoom out a bit so you can see that nicely. And then we're going to go below this p tag and render another p tag that's going to have a class name of help to provide some additional information, such as the info that the maximum file size is, I'm not sure whether it's going to be 10 or 50 megabytes, but for now, let's set it to 50 megabytes, like this. Perfect. And now we can figure out what happens if we have already uploaded a file. That's going to be happening within this second div right here. That's going to have a class name set to upload-status. So we can show the status while it's being uploaded, with a div of class name set to status-content, and a div with a class name set to status-icon. And we're going to check if progress is set to 100. In that case, we will display a check circle 2, which means that it's going to simply be classified as checked, like a check mark. And if the progress is not 100, then we will display an image icon coming from Lucid React with a class name set to image, and we can close it right here. Of course, we can't see that right now because we haven't yet uploaded an image. Then below this div, after it is uploaded, we can render an h3 that'll display the file.name. And below that h3, we'll display a div that'll actually keep track of the progress. So it'll have a class name of progress and a div with a class name set to bar, as in progress bar. And this progress bar will have a style where we will modify its width to give it as many percentage points as the progress has progressed. And this is going to be a self-closing div. So it's basically going to move from left to right until it fills 100, and then we're going to display a check mark. Then right below this self-closing div, still within the progress div, I'll render a p tag with a class name set to status-text, and we'll say if progress is lower than 100, then the text can say something like analyzing floor plan ... Else we'll say redirecting, because we want to display the AI result to the user if the progress has reached 100. Perfect. Now, for this to work, we have to keep track of a lot of different constants, such as by how much we're going to increment this progress as it moves. What happens if we have a 401 or 403 error? Or what are going to be the dimensions of the image that we display right here? And most importantly, how's the prompt going to look like that's going to take this 2D floor plan and turn it into the 3D architectural render? We don't want to store any of that information directly within this component. Instead, we want to create a new file within the lib folder called constants.ts. And I'll provide you with this constants file in the video kit link down in the description, so you can simply copy it and paste it here. You'll notice that this simply includes some storage paths as to where we're going to store the final images, the timing constants for the progress, as I was telling you about, some UI constants, image dimensions, and then most importantly, the Roomify render prompt. I took some time to actually write it to make sure that it gives the best output as possible. So let's go ahead and go through it together. The task is to convert the input 2D floor plan into a photorealistic top-down 3D architectural render. I give it some strict requirements and ask it please do not violate them. Remove all text from the render. Do not render any letters, numbers, labels, dimensions, or so on. Geometry must match, so walls, rooms, doors, and windows must follow the exact lines and positions in the plan. Do not shift or resize. We want to make sure that it provides clean, realistic output with crisp edges, balanced lighting, and realistic materials. And we ask it to not add anything else. All the walls, doors, and windows must be copied from the 2D render. And then we also ask it to add some furniture and room mappings where if they were clearly shown in the original 2D plan, something like a bed icon, sofa, dining table, and so on. And we ask it to make the lighting bright and neutral. Great. So we'll use this when creating the render of our application. And now is the time that we implement the actual drag and drop upload logic. But if you have ever done drag and drop, you know how it's a very manual process. It's simple, yet requires a lot of code to get done properly. So this is a perfect situation where we can use AI to do it for us. So go ahead and open up Juni, and let's give it a task to create the upload drag and drop functionality. I'll give you the full prompt in the video kit link down in the description, and once you paste it, we can go through it together. Update the upload component by adding drag and drop handlers and an onChange function that passes files to a new process file function. Inside of that function, use the file reader functionality to get a base 64 string and increment the progress using constants. When progress reaches 100, clear the interval and call the onComplete with that data after a specific delay. Ensure the upload logic is block if signed in is false and the drop zone UI reflects the is dragging state. Again, I was super descriptive right here just because I want you to have the same output as I have. But if I was developing this myself, I literally could have told it, go ahead and implement the drag and drop upload functionality, and I'm pretty sure Juni will do it well. So let's go ahead and give it this task and see how it does. It's editing the upload file, and it looks like it's gonna do it pretty quickly. There we go, it's done. It updated the homepage where it basically just provided some additional props to it. For now, it's just console logging the upload complete functionality, but most of the logic actually happens within the upload.tsx file. So let's go ahead and open it and see what it did. It added some upload props so we know when it is complete. And then it created this process file function. And it even used use callback to make sure that it is cached. We check whether we're not logged in. And if that's the case, we exit out of the function. But if we are, we update the file that the user wants to upload and reset the progress to 0. Then we read the file from the base64 image. We set the interval to continuously update the progress of the upload, and then we read the file. We also implement the drag over, drag leave, and drag drop functionalities. When we drop it, we simply process the file. Or when we just manually select an image, again, we process the file. So let's go ahead and test it out. If you're not renovating an apartment yourself, you can go ahead and search for a simple 2D floor plan on Google, and then head back over to the app you developed, and then simply drag and drop it in. You can see how it nicely reacts when you hover over it. And upload and check mark, it's all looking great. Right now, our code is not doing anything with that file. But if I'm not mistaken, if you head over to our routes home, we are console logging the complete upload. So if you head over here and open up inspect element and go to the console, you should be able to see the base 64 version of that completed upload, which is good. Means that we have some data to work with. But now we actually want to visualize that file. And to do that, we can create a new route under routes and call it visualizer dot $ID dot tsx. This is how you can create a dynamic file within React Router. You can initialize it using RAFCE, and you need to add this new route within routes.ts. For now, we simply have the index home route, but you can separate it by comma and add a new route coming from React Router dev routes. The route is going to be visualizer /:ID because it's going to be a dynamic route. And the file is going to be /routes /visualizer $ID.tsx. And finally, we want to modify the onComplete of our homepage, that is right here, so that it doesn't just console log it, but it actually redirects us to this visualizer page. We can create this new function at the top of the component by getting access to navigate, which is coming from the use navigate hook, which you have to import from React Router. And then you can say const handle upload complete, which is equal to an asynchronous function that accepts the base 64 image of a type string. And we can open up a function block. We want to get access to the ID of this image, but we have to create it. So the simplest way to create a new ID is to just get the current date and turn it to string. That's pretty unique. And then we can navigate over to /visualizer / this new ID of the new plan that we just created, and then return true. So now right here, when we upload, instead of console logging it, which is right here, we can instead call the handle upload complete. It'll automatically get in the newly uploaded image, and it'll receive this base 64 image, and it should perform a redirect. So let's test it out. I will upload a new file, and it redirects us to a 404. That's because we get moved over to visualize, but instead it should have been visualizer. So if I fix it, go back and re-upload, you'll see that this time we get back to our visualizer ID, which soon enough is going to become a dynamic page where we can actually display this image. But before we do that, let's go ahead and open up a new PR for this drag and drop uploader component that we created. Or if I'm being more precise, the drag and drop functionality was created by AI. It's interesting that CodeRabbit themselves recently did a report on the state of AI versus human code, and the main finding is that AI code creates 1.7 times more problems. I mean, it speeds us up significantly, but then it's likely that we didn't check it out in detail, so it has more problems. And for that exact reason, let's go ahead and push the changes so far on this new branch. Don't forget, we are on the upload files branch, and we have just implemented that feature. So we can say git add dot, git commit -m, implement, drag and drop uploader, and git push. And of course, since we created a new branch, we have to set it upstream. So copy and paste this command, and then directly within your GitHub repo, you'll see that upload files had recent pushes 2 seconds ago, which means that we can compare it with our main branch, see where we have made some changes, specifically in 7 different files. And then before we go ahead and merge this PR, you should be able to see CodeRabbit pop up just now, and it says edge cases are just center cases in disguise. So let's give it a minute until it reviews the PR so we can be sure that it doesn't have any problems. And then if that is the case, we can proceed. And within just a minute, since this is a very simple PR, we get a summary created by CodeRabbit, where in this feature, we have added image upload capability with drag and drop support, upload progress tracking with visual progress bar, new visualizer view for processing the uploaded images, and then automatic navigation to the visualizer after upload completion. CodeRabbit gives you an even deeper walkthrough if you need it, alongside this nifty little code diagram that we can expand and check out. This is actually a detailed one. So it shows us how the application is working up to this point, and specifically regarding the feature we are implementing in this PR. So maybe like another human working in your team who is reviewing this PR can more easily understand what this is all about, or if you need a recap of how this works or a sanity check if it works correctly, you can go ahead and check it out. So in this case, the user is navigating to the home page. It has the home route right here. We then render the upload component with onComplete callback. The user selects or drops the image file. We're checking if the user is signed in. If they're authenticated, we read the file as base64, animate the progress bar, complete the progress, and then call onComplete, which generates a unique file ID and navigates over to the Visualizer ID page, which we then display over to the user. But if the user is not authenticated, we disable all upload interactions. This is exactly what we wanted to happen. In this case, we have a couple of comments. It's interesting, we actually have a critical potential issue within the application, even though it's a super small PR. So uploaded image data, base64 image, is discarded. The visualizer page won't have access to it. I mean, yeah, we know we're not currently displaying it. So it's basically telling us that we need to pass this base64 image to this new page. That's coming up in the next lesson. It's also talking about a potential inconsistency. Yep, here we mention up to 10 megabytes, that's on the homepage, but then in the actual upload, we mention 50. We gotta be a bit more consistent because otherwise our users are gonna complain and they don't know which source is true. And there's another critical issue where the set interval and set timeout are never cleaned up on unmount. If the component unmounts while the progress animation is running, such as user navigates away, both the interval and the timeout will continue firing, which can potentially invoke onComplete unexpectedly. So it proposed a fix where we can clear those intervals. You can either manually copy and paste these fixes, or you can just use this prompt for an AI agent to implement it for you. Let me try doing that. I'll head back over into our application, open up Juni right here, and simply paste what CodeRabbit gave me. Clean up timers in upload component on unmount. And while that is happening, let's see what else is happening. Missing file reader error handling. Okay, so if the read as data URL fails, such as file read error, there's no reader.on error component. So we definitely need to add it. Right below the const reader new file, we can add the reader on error. So let's go ahead and do that. And in the meantime, looks like the changes were properly implemented, which is good. And I'll head over to the upload component. So below where we actually have the reader, we can also add the reader.on error. And that way we're keeping track if something goes wrong. Perfect. Oh, this is a good one. Drag and drop accepts any image type, but the file inputs restricts to these files. So the suggested fix is to simply specify the allowed types for the drag and drop as well. This is going to be below the dropped file right here. So we can exchange these lines with the allowed file. So below the dropped file, we can paste what we just copied, and these include the new allowed types. So we can say if dropped file exists and allowed types include one of these allowed types, then we can process the file. And with that, we are done with the review. So let's go ahead and push those changes by saying git add dot, git commit, implement, CodeRabbit suggested fixes, and git push. To be honest, this was a super small PR, and I didn't anticipate that CodeRabbit will have so many critical, some minor, and some major issues. But it actually found some nice fixes that AI forgot to add. So this is a win in my book. Since we pushed the changes, let's go ahead and merge this pull request. And then we can go back into the code, switch back over to main by running git checkout main, and then git pull to pull the latest changes. And then we can create another branch by running git checkout -b hosting images. That's going to be the next thing we want to focus on, actually displaying our images within the visualizer and hosting them somewhere. So let's do that next. Okay, so we're using Puter to develop Roomify, but how does it actually handle the heavy lifting? And why use Puter's tools instead of a traditional setup like an SQL database or a cloud provider? Well, in a typical app, you'd rent a server, set up Postgres, manage S3 buckets for images, and juggle a dozen API keys just to get started. Puter gives you a unified environment where everything talks to each other out of the box. So let me quickly walk you through the three pillars we'll use. First, there's KV, Zero Config Database. For an app like Roomify, you don't necessarily need complex SQL tables and joins. You just need to save and grab project data fast. Puter KV is a key value store. Think of it as a high-speed dictionary. You call puter.kv.set from the front end, and it's saved in the cloud. No server, no connection strings. And here's the best part. Each user stores their own data in their own Puter account. So your infrastructure costs stay at zero, no matter how many users you have. Then there's the file system and hosting for image storage and delivery. Images are big, and if you shove them into a database, everything slows down. Normally, you'd use something like AWS S3, which requires backend signing and permissions, but here we use Puter file system to write the image files and Puter hosting to serve them. File system writes the file to the user's cloud storage. Hosting takes that folder and instantly turns it into a live URL, something like roomify-xyz.puter.site. Professional-grade image delivery without ever leaving the front end. And then there are workers, the secure backend part. So if Puter handles so much on the front end, why do we need workers at all? Well, client-side has one weakness: privacy. The Puter SDK only lets a user see their own files. But if you want to share a Roomify project with a friend, their browser can't access your storage. Workers act as your backend API. They run with your developer identity so they can bridge the gap between users and keep sensitive logic off the client. So that's our stack. KV handles records, FS plus hosting handles images, workers handle security. No server setup, just focusing on features. And throughout the rest of this course, I'll teach you how to use and implement every single one of the features I just explained. Let's get into it. To get started with hosting our uploaded floor plan to the web, we can create a new file within the lib folder, and you can call it puter.hosting.ts. This file will handle the upload of the images to the Puter hosted domain. Within this file, we need to create a function that checks if a subdomain is present in the key value store, Puter's database. If not, it needs to create a new one and then store that subdomain in key value pairs. So let's create a new function by saying export const get or create hosting config. And this one will be equal to an asynchronous function that will return a promise, which will then be resolved in the hosting config, like this, or null if it doesn't exist, and we can open up a function block right here. Now, this hosting config is a type, which we can declare right here. Type hosting config is going to be equal to an object that'll contain a subdomain of a type string. And I'll also add a new type for the hosted asset, which is going to include a URL of a type string. Perfect. So now we have to actually implement this function. Within this function, at the start, we can try to get access to the existing database or a chain of key value pairs coming from Puter. So I'll say const existing is equal to, I'll put it within parentheses and say await Puter, which you have to import, .kv .get, and we need to pass a hosting config key. This config key we can create within a new file right here under lib, and you can call it utils.ts. Here we can export and create this new hosting config key, which is going to be equal to Roomify hosting config, like this. And while we're here, we can also export a hosting domain suffix, which is going to be equal to .puter.site. So we don't have to repeat it every now and then. because if you're repeating strings, you can make a typo or a mistake. But if you have a variable like this, then it's always going to be correct. So now we can go back right here and we can pass this hosting config key right into it, coming from utils. And we can say as either hosting config or null. Perfect. So now the only thing we have to do is check whether a subdomain exists. So if existing !dot subdomain, in that case, we will simply return an object saying subdomain, and we'll set it to existing dot subdomain. And of course, I have to return this part right here. But then if the subdomain doesn't exist, we'll say const subdomain is equal to create hosting slug. And this is a function that we will create, but we don't want to clutter this file with all the logic. So instead, I'll create this new function within the utils. So head over into lib utils and create and export a new create hosting slug, which is going to immediately return, that means no curly braces, a template string that's going to start with roomify dash, we can do date.now dot toString 36 dash, and then we can randomize it again by saying math.random dot toString of 36 dot slice. Let's do it from 2 to 8. So we have really randomized this hosting slug. So now we are exporting it and we can just import it from the utils right here at the top. Then once we create this new subdomain, we can open up a try and catch block. If there's an error, we can just use a console.warn and we can say something like could not find subdomain or failed creating hosting, and then we can return null. Or once we successfully get the subdomain, we can actually create a new Puter hosting by saying const created is equal to await Puter.hosting.create, and we can pass in the subdomain. And as the second parameter to this .create, if you hover over it, you can see that you can pass the directory path, which I will simply set to dot to do it in the current directory. And then we can get access to the record, which is going to be subdomain. And now we're going to set it to created.subdomain instead of the existing one that we had above. And finally, we need to return it. That way, we are returning it either way, here if we get it from the existing one, or here if we create a new one. Of course, you have to say return record. And in that case, you can see that this function will not complain because it is successfully returning the hosting config. Here, creating this variable is redundant, so what you can do is just return the object directly. And now, in the same file, right below this get or create hosting config, we can implement an upload function that takes blobs or base64 strings and uploads them on the Puter subdomain. So let's do it right here by saying export const upload image to hosting, and that's going to be equal to an asynchronous function that's going to accept a couple of params such as hosting, URL, project ID, and label, and those will be of a type store hosted image params, and it'll return a promise that will resolve in a hosted asset. We have that right above, hosted asset, or null. And then we can open up a function block. Now, here we have a lot of different types. Sure, we could have defined these types like hosting is string, URL is string, and all of that above, but we don't necessarily want to clutter this file with a lot of unnecessary types. So instead, we can declare this type right within our type.d.ts. That's going to be an interface for the store hosted params. But instead of typing all of these by hand, I'll provide you with the final type.d.ts file so you get all the types that we'll use throughout this application. You can see that it starts with the auth state that we already had, some things like the materials which we'll use, the design item, everything that it's going to have, as well as different statuses within the application, and then these store hosted params that we're adding right now. There are also these two hosting config and hosted assets that we use right here. So no longer do we have to define them here. They're automatically being imported since they are within the type.d.ts. So the entire application has access to them. Now, to implement this upload image to hosting, we'll also need a lot of additional utility functions that are going to make it easier for us to implement the hosting. So head over into utils.ts, where we have just created some constants, as well as a basic create hosting select function. And within the video kit link down in the description, you can find the full utils.ts file. So simply copy it and paste it over here. If we collapse some of these functions, you're going to notice that it just includes some utils to help us transform the data from the URL to a blob, get us the image extension, it is JPEG or SVG or something like that, and get the hosted URL. So this part right here is mostly some code that is used within a lot of different applications, and that is mostly boilerplate. So I actually used AI to generate it. Once you have it here, you can head back over to this file and we can start creating this function. First, let's do some checks. If there's no hosting or there's no URL, we can simply return null. Without that, we cannot upload. Also, if there is hosted URL to which we need to pass the URL, then we need to return that URL and that's it. We're doing everything we need to. After that, we can open up a try and catch block. In the catch, we can simply warn about that error by saying console.warn could not find hosting URL, or we can also say something like failed to store the hosted image, and then display the error and the return null. But if everything goes right, what we can do here is we can try to resolve the transformation of the image from the URL to a PNG. We can do that by saying const resolved or resolved transformation, and we'll check if the label is triple equal to rendered. If that is the case, we'll say await image URL to PNG blob, to which we're going to pass this URL. So this is coming from the lib, and I'll actually put this in a new line so it's easier to see. And I'll call a .then on it that gives us access to the blob. And if a blob exists, then we want to return an object containing the blob and a content type set to image/PNG. Else, we want to return null. So let's actually put it into multiple lines. First of all, rendered should be a string. So if label is rendered, we're then awaiting image URL to blob and then calling a .then on it. And then if it's not rendered right now, we can just await fetch blob from URL and pass in the URL. Finally, if it's not resolved, we can return null. And of course, this fetch blob from URL has to be imported, and to it we have to pass a lowercase URL. There we go. But if we have resolved the image that we have uploaded, in that case, we can get access to its content type by making it equal to resolved.contentType or resolved.blob.type. Or if that doesn't exist, well, then it's an empty string. Then we can get the image extension by saying const ext is equal to get image extension. This is another one of those utility functions we have created in the lib utils. And we need to pass the content type as well as the URL so we can extract the actual extension. Then we can extract the directory by saying projects / and then project ID. This is where this image will be stored. And then finally, the full file path, which is going to be equal to dir directory. And then it's actually going to be the label dot extension. So we're combining all of those into a final file path. Finally, we have to figure out which file we want to upload. And we can create a new file out of these blobs that we got access to by passing in the file bits, which is going to be resolved.blob. And then for the second parameter, we need to pass the file name, which is going to be label.extension one more time. And then as the third parameter, we can pass some additional options. Type is set to content type which we extracted not that long ago. It's basically defined right here when we were creating this image. And finally, we have to use Puter to upload it. So right below, I'll say await Puter.fs as in file system, mkdir to create a new directory, and create missing parents will be set to true in case we're creating this directory for the first time. Then await Puter.fs, again entering the file system, but this time we're going to write within it. Specifically, we're going to write something to the following file path, and the data that we're going to add is going to be the upload file. That's going to give us access to the hosted URL of the uploaded image. So say const hosted URL is equal to get hosted URL coming from our lib. And then we can define the subdomain of hosting.subdomain. And as the second parameter, we can provide the file path so we know exactly where it is coming from. And once that is good, we're going to simply return the hosted URL. If it exists, then the URL will be set to hosted URL, else we'll simply set it to null. And this was supposed to be hosted URL like this. Perfect. So now we can see our TypeScript is not complaining, and we have implemented a function which will eventually allow us to upload images to our file storage provided by Puter. But of course, the upload functionality is not yet done because we have to call this function somewhere. So let's do that in the next lesson. Now we gotta get back to the Puter.actions.ts file, and where we have our sign in, sign out, and get current user function, which are all authentication functions, we want to add a new function, the one to create a new project. This function will take the project info as parameters, and when I'm talking about the project info, I'm talking about these projects right here, such as the title, the date, and then finally the uploaded image as well, so we can then move all that data to our AI, which is then going to create this architectural render. The project function should take all this information and the image and store it to the key value database. We'll implement the key value storage within workers lesson later on, but for now, this function will call other functions we implemented in the last lesson when hosting the images and create their URLs. So let's create it by saying export const create project, which is going to be equal to an asynchronous function that takes in an object containing the item, the information about the project we're creating, of a type create project params, and it'll return a promise which gets resolved in a design item or null or undefined. And then finally, we can create a function block. Now, this design item will need to have its ID, the name, the source image, source path, and then the rendered image and rendered path and the public path where we have deployed it, as well as the owner ID. So right here, let's say const project ID is equal to item.id. And then we need to get access to the hosting that we worked so hard to create the last lesson. So say await get or create hosting config. And then we want to get access to the hosted project by saying hosted source is equal to, if a project ID exists, in that case, we want to await upload image to hosting, and we need to pass all the information, such as the hosting itself, the URL, which is equal to item.sourceImage, the project ID, and finally, the label, which is going to be set to source. Or if we don't have the project ID, then there's nothing to host. Finally, we want to get access to this hosted render by saying const hosted render is equal to, and we're going to check whether we have access to the project ID and item.rendered image. And if that is the case, we will await upload image to hosting. And then we want to pass almost the same parameters as before. So that's going to be hosting URL, but it's not going to be the source image. Rather, it's going to be the rendered image. Project ID is the same, and this label is rendered. So we need to have both the before and after images right here. I think this fits into one line, so we can do it like this. There we go. Or it's going to be set to null. And now we have both the hosted source and the hosted render. So now we need to resolve it by saying const resolved source is set to hosted source.url to check whether we have it. And then we can do another check, is hosted URL, to which we can pass the item.source image. And if it is, we'll return the item.source image, else we'll return an empty string. And I think we can also put this in a new line like this, so we know what's happening. Finally, let's do a quick check to see whether we have the resolved source. If there is no resolved source, we can simply open up a new function block and say console.warn failed to host source image, skipping save. And then we can return null. But if everything is properly resolved, we also want to get access to the resolved render, because here we had the resolved source, and remember that we have to do everything twice. So right here, I'll say const resolved render is equal to hosted render $.url. And if we have that, then we can get it from hosted render.url. Else, we can make a check and see whether we have the item.rendered image, and if is hosted URL is set to item.rendered image. If that is the case, we'll simply return the rendered image, else we will return undefined. So this allows us to get the resolved render as well. And finally, now that we have all of that, we can form it into this new object that we want to create that has to look like the design item, containing all of these different pieces of info. So that's going to look like this, const, and we can destructure some variables from the item. So like this, we'll destructure the source path, and we'll rename it to underscore source path, like so. We'll also get access to the rendered path and rename it to rendered path. And finally, do the same thing for the public path. And then we can spread the rest of the values right here coming from the item. Once we spread all of that, we only need to get the ones that we believe are useful for the design item by forming them into an object payload, which we'll send over to Puter. So we'll first get the rest, we'll then get the source image and set it to resolved source, and finally we'll get the rendered image and we'll set it to the resolved render. And now we can open up a try and catch block. In the catch, we can get the error, but we can simply console log it, saying something like failed to save project, and then we can display the error and return null. But in this case, if everything goes right, we have to call the Puter worker to store project in KV. This is the key value database. For now, though, we'll simply return the payload. Later on, once we implement the Puter worker, we can save it in the database. So now I just want to test it out and see if we get this payload out by calling this create project function in our homepage. So head over to our routes, home, and then right at the top of the home, we can create a new use state snippet called projects and set projects at the start equal to an empty array, and it'll be of a type design item array like this. And of course, don't forget to import use state coming from React. So now that we have the projects, right here under handle upload complete, instead of simply re-navigating, we can actually create a new project. So first we get the new ID, then we get a name. For example, all the names can start with residence, and then we can give it the new ID, and then we can get a new item with all the data that we need to pass, containing the ID set to the new ID, the name, which is going to be just name, source image, which is going to be that base 64 image coming through params, the rendered image, which at the start will be set to undefined because we don't have it yet, and then finally the timestamp, which is going to be set to date.now. And with that, we have everything we need to create this new project. So we can call this function we created, const saved is equal to await create project, which we're going to import. And we need to pass in the item, which is going to be new item, And we can choose the visibility right here, whether we want to make it private or public. Then, if we have not saved it successfully, if it doesn't exist, we're simply going to render a console.error that's going to say failed to create project, and it'll return false. But if we have created a project successfully, we can simply set projects, the one in the state, where we can take access to the previous state of the projects, spread them out, and then append a new item. But instead of appending it, making it come to the end, we want to prepend it so it actually comes on top, like this. Finally, we want to navigate over to this new visualizer, but we also want to provide some additional state. If you remember correctly, this is exactly what CodeRabbit complained about before, saying that, yeah, we have this base64 image right here, but we're not doing anything with it yet. So we want to pass it as state into this new component by passing the initial image, saved.source image, as well as passing the initial render we created coming from saved.rendered image, or null if it doesn't exist, and the name of the project. We'll then use these later on within the visualizer to display the before and the after. So now that we have the real projects right here, we can actually map over them within the projects grid, because currently we have just one fake preview card. So right above this project card, you can say projects.map, where we're going to destructure the ID, the name, the rendered image, the source image, and the timestamp. And we're going to automatically return this project card group. So take the entire div with the project card group and just put it within here so we can actually return multiple cards, not just a single one. Let's make sure we're properly enclosing it. I think I closed this brace too early. So instead, we need to have it here and here, and then add another one here. Then you'll see that projects is not defined. Let's see if we have named it something else. Yep, I misspelled it. So it's going to be projects and set projects. And now we're back online, but you can see that we don't have any projects yet. That's because we haven't created them yet. But now at least we can render the real data. For example, for this H3, instead of this fake name, we can render a real name. For the date, we can render the new date and then pass in the timestamp. Then for the span, we can leave it as it is right now. But what I want to change is going to be this image. So right here under the source, we're going to pass in a rendered image, or if we don't have it, then a source image with an alt tag of project, like this. Perfect. And it looks like we have a little error right here saying that we are currently passing a new date with a timestamp, but we have to remove this object sign right here. It just accepts a timestamp instead. Other than that, this was supposed to be set projects. And then we're good. So now we can head over into the visualizer and actually implement it. Currently, it is just fully empty. How can we get access to that state that we passed into this new page? Well, by using the location, which is going to be equal to use location coming from React Router. And then from it, we can extract the initial image and the name, which is going to be coming from location.state or an empty object, just to ensure it doesn't break. Now, once we get the name and the initial image, we can simply display it within a section. We're going to have an H1 that'll have a name, or if we don't have a name, it'll render something like untitled project. And then below the H1, we'll render a div with a class name set to visualizer. And then within it, if an initial image exists, we will render a div, which we can close right here. And this div will have a class name set to image container with an H2 rendering the source image, and then below it, an image with a source of initial image and an alt tag of source. And then later on, we'll develop a component that allow us to see the before and after. But with that said, it's now time to test the entire flow of uploading a floor plan image. So when you upload this floor plan, you'll see that it'll get uploaded. For a second, you might have seen that it showed it under the project cards. And then here we can see the information about this architectural project, such as residence and then the ID, and then the source image right here, which just contains some basic 2D floor plan. But now, if you right-click on this image and say Open Image in a new tab, you'll be able to see the source is now stored under Roomify dash, and then we have some unique ID, .puter.site/projects. We have our own project, and then source.jpg. This means that we have successfully uploaded and hosted this image to the internet, specifically onto Puter, which is hosting it for us. This is great, and we're getting so much closer to generating an actual 3D architectural render of this design. But we've just made sure that the upload functionality works and hosting the image, which was our task for this pull request. So let's go ahead and check the branch we're on. Hopefully you created a new branch called hosting images. You can run git add dot, git commit -m, host and upload images, and then you can run git push. Of course, you'll have to set the upstream for this new branch we created on GitHub. Then, if you head over to GitHub, you'll see your hosting images branch has a new PR. So let's open it up and let's give it a check. We removed 45 lines, added 445. So this is definitely a review that I want CodeRabbit to do a detailed run through for. So let's let it do its thing, which is winning the war on bugs one line at a time. And very quickly, we get a full walkthrough of what we implemented. This was a big one, so let's see what it adds. We implemented project persistence and retrieval functionality by introducing hosting utilities for image uploads, a project creation action that prepares and saves project data with hosted assets, enables dynamic project listing on the homepage, and updates the visualizer to consume the project state from the router navigation. The diagram now looks a bit more like this. The user uploads the image, then we call the create project action, which then gets the hosting configuration. We then either retrieve or create the hosting config using the Puter API, which returns us the subdomain and the hosting configuration, which means that we can start uploading the image to hosting. We convert the image blob, write this new file to the hosting file system, specifically with Puter API, which then confirms it and returns us the hosted URL. Then we can finally return the entire design item containing all the information about the project, as well as the uploaded and hosted image. And then we navigate over to the visualizer, which renders, extracts the initial image and name, and displays the project to the user. Of course, our next goal is going to be to create that AI architectural 3D render, which we'll do soon, so we can display that on the visualizer as well. This was a fairly complex code review, so let's see what CodeRabbit has to say about it. As usual, there are some nitpicky comments. These typically aren't a big deal, but you can check them if you want to. And then we have some more minor and critical issues. First of all, the local state stores the pre-upload item instead of the saved payload. Interesting. Set projects inserts the new item, which has the raw base64 source image, rather than the saved, which has the hosted URL. This means that the project cards render base64 encoded images in images source, which works, but is inconsistent with the persisted data and bloats memory for larger images. Okay, did I actually miss this part? The proposed fix is simply to add the saved one, which contains the URL of the image instead of the raw base64 image, which is huge and just bloats the memory. So we can very quickly fix this, and CodeRabbit here gives us an instant commit change. So if you just commit it like this, so now if you go back right here and search for saved projects, I believe that was in the home, saved projects, or create projects, there we go. The new item is here, but now if you open up your terminal and pull the latest changes by running git pull, you'll be able to see that now it got updated to save. So this is another way that CodeRabbit can very quickly make changes. There's a critical one saying that we're missing the key property on the map project card. Yes, this is indeed a big one because React needs a stable key on each element to correctly reconcile the DOM. We already have the ID, so we simply need to use it. And in this case, we also get a committable suggestion that adds a key equal to ID. So let's commit it. That's pretty simple. Then we have another one, which is major, saying no fallback data fetching when location state is absent. If a user refreshes the page, shares the URL, or navigates directly to the visualizer ID, location state will be null. But since the route already carries the ID, we can consider loading the project from persistence, for example from Puter.js when state is missing, so the page remains functional outside of in-app navigation. We're going to surely implement this later on. We're not just going to pass the state. So more on this soon, but this was a nice catch from CodeRabbit. And then we have persistence is stopped out, create project doesn't actually save anything. Well, yes, that is the case. We are not yet creating the project officially. And that's because we need to call the Puter worker to not only save the initial image, but we also want to use AI to create this new 3D architectural render and then store all of that together in KV. But CodeRabbit nicely asks us whether we need some help implementing this. Don't worry, we're going to do that soon. And this is critical. Newly created hosting config is never persisted to KV. It reads it, but after creating a new subdomain, it never writes it back with Puter KV set. This means that every invocation sees existing as null, generates a new random slug, creates a new hosting subdomain, while previously uploaded assets live under an older subdomain that is never recalled. If this is true, this is definitely a big issue. So what we have to do is get access to the config and then set it to Puter and then return it. So yeah, this is potentially a huge issue that I completely missed. And CodeRabbit gave us a proposed fix. So I'm actually pretty stunned with how it was able to find the exact line that I missed and that messes up with our functionality. So back into the code, you can head over into the puter.actions.ts and navigate over to get or create hosting config. What we're doing here is checking our key value database. If it exists, we simply return. If not, we create new hosting. Then we return the subdomain, and we never actually save this new subdomain to the database. So in the next call, the existing will again be null, which means that it'll recreate it every single time. So what we have to do is save this record. And then once we save it, we can await puter.kv.set and add this new record to the hosting config and then return it. This way, it won't try to recreate it every single time. This was an amazing catch by CodeRabbit. So let me go ahead and push the changes by running git add dot, git commit, fix CodeRabbit suggested bugs, and then push. Oh, looks like we forgot to pull first. So let's do git pull. And we cannot do pull because we have added additional changes later, but we can do a git pull with a -- rebase. And now we can do git push. So now we are up to date with the latest changes, which includes the changes we have added automatically with CodeRabbit, as well as this big change that we implemented ourselves. And now we can go ahead and merge this PR. This was huge. So with that in mind, we're now successfully creating a new project. But of course, the goal is not just for us to create the ID with some kind of a reference and then the current 2D image. The goal is to create a whole 3D architectural render of this boring 2D design. So let's do that together in the next lesson. And finally, it is the time to generate our 3D AI design off of the 2D file that we pass in. So we can do that within lib and actually want to create a new file within it, which is going to be called ai.action.ts, because this file is going to be all about generating that 3D design out of the 2D floor plan. Back within Puter docs, you can see that there's a puter.ai.text-to-image function. Given a prompt, generate an image using AI. It's already built in. We simply need to pass the prompt, some options, and that's it. But if you pay a close attention to the input image, you can notice that it requires a base64 encoded input image for image-to-image generation. And since we have already hosted our image, we now need to convert it into base64 before sending it into the AI model. To do that, we can create a new function that'll take the URL and turn it into a base64 string using AI. So another great opportunity for Juni, where we can tell it to write a TypeScript function called fetch as data URL in lib AI action TS that takes a URL string and returns a promise string. First, use fetch to get the image and throw an error if the response fails. Then convert the response into a blob. And finally, create a new promise that uses a file reader to read the blob as a data URL and resolves with a result or rejects on error. Let's see how well it does it. This code should be implemented within the AI action fetch as data URL. We fetch the URL. If there is no response, simply throw an error. But if there is one, simply try to access a blob version of that image, read it as a file, and return it. This is going to be enough for us to create a new function called export const generate 3D view, which is going to use that file that we extracted from this function above. It's going to be an asynchronous function that accepts the source image of a type generate 3D view params, and then we can return a new function block. So here we can get the data URL, which is going to be equal to source image dot starts with a string of data like this. And if that is the case, then we can just return the source image. Else we can await fetch as data URL and then pass it. That way we'll make sure to have the image in this data file format. Then we can take this base 64 data and split it to extract only what we need. So data URL dot split by commas, and then we only want to get the second part of it. And then const mime type is equal to data URL dot split. We're going to split it by a semicolon, and we're going to take the first part out of it, and then we're going to split it again by using the colon and then getting the second part out of it. This is going to give us the type of the image. If we don't have any of these two parts, so if there is no mime type, or if there is no base 64 data, in that case, we simply want to throw a new error saying something like invalid source image payload. But if we have properly extracted this source image, we can then generate a response by calling await Puter.ai.text2image. This is that function that we have seen right here. Of course, we have to import Puter from it, coming from heyputer/Puter.js. And then to it, we can pass some options. The same options that we can see right here. Of course, we'll first need a provider. You can choose from many different providers. In this case, I found Gemini to work the best. Then you can choose a model. In this case, I'll go with Gemini 2.5 Flash Image Preview. We can also pass the input image, which is going to be the base 64 data, which we created. And we also have to pass the input image type. That's going to look like this, and it's going to be the type we extracted above. We can also pass a ratio, which in this case we can set to width of 124 and height of 124 as well. So that's going to look like this. And with that, our text to image shouldn't complain anymore because it's receiving all the right props. But in this case, I misspelled it. It's actually txt to img, like this. And then the first param that it actually requires, which we can also read right here, is going to be the prompt, and only then the options. So the prompt we have already created under Roomify render prompt, coming from our constants. So now if you command click into it, you'll see exactly the prompt we're using. This is the one that we explored earlier. Of course, you can play with this prompt further to get even better results. Now, you can still see that under text to image, we still have red squiggly lines, meaning that there's a type mismatch. It's saying that the input image is currently getting as a string array, and instead it has to be just a string. That means that we haven't properly split it right here, and that's because I put this first part inside of the split instead of outside of it. If we do it like that, it'll now get the proper base 64 data. Perfect. Now we can get this raw image URL, coming from response as HTML image element dot src. Or if it doesn't exist, it can be set to null. Then if we don't have access to this raw image URL, we can simply not throw an error, but rather return rendered image set to null and rendered path set to undefined. But if we have the raw image URL, then we can actually return it by saying const rendered image is equal to raw image URL dot starts with. And if it starts with data like this, in that case, we can just return this raw image URL. Else we can await fetch as data URL and then pass this raw image URL right here. Either way, we are returning the rendered image properly. So now we can return an object consisted of that rendered image and the rendered path, which for now we can leave as undefined. And now we can actually call this generate 3D view function within our visualizer to be able to display the generated result. So head over into app routes visualizer. Let's also get access to navigate right here on top of the location, which is also coming from React Router in case we need to re-navigate back to home. And let's also create a single ref called has initial generated, which is going to be equal to a use ref initially set to false. Then we can add additional use states. That's going to be a use state snippet is processing and set is processing at the start set to false. Of course, we'll have to import use state coming from React. And then we can do the same thing for the current image by creating a new use state snippet called current image and set current image, which can be at the start set to either the initial render, which we'll get access to through the state when we transition over from the homepage when we upload a new project. So initial render will be coming through here. But if we don't yet have it, we can just set it to null, which means that this state can either be the state of string or null. Then in case we want to go back, we can create this handle back functionality, which is going to simply navigate us back to the homepage. And the most important function is going to be called run generation, which is going to be an asynchronous function that's going to check whether we have access to the initial image. If we don't have access to it, we're going to simply exit. But if we do, we can try to generate this 3D view. So right here in the try block, I'll set is processing to true, so we can display some kind of a loading because AI generations take time. And then we'll try to extract the result out of the call to our generate 3D view function, the one we created in this AI file not that long ago. And to it, we can pass the source image set to the initial image right here. And if we get back the result dot rendered image, in that case, we can set it to the current image state by setting the result dot rendered image right here. Now, once we get this image, we'll also have to update the project in the database with the rendered image. Because think about it, the project in key value pair database only consists the data about the initial project name, its ID, and also the initial floor plan. But now that we have this new image, we'll have to update it. But for now, let's just create a new catch block right here. And if there's an error, we can simply console.error it by saying generation failed, and then display this actual error. And we can also display a finally block to set the processing to false, whether it succeeded or failed. Finally, right below it, we'll create a new use effect to keep track of the changes. So whether we only have the initial image or we have the initial render, we want to know what is the state. So if there is no initial image and has initial generated dot current is also not true, in that case, we'll simply exit out of this use effect. But else, if we have the initial render, we'll then simply set it to the current image right here, to the state, so we can display it. And we're going to also update this ref by saying has initial generated, that current set to true, and then we're going to exit. Outside of it, we can also set this has initial generated to true, and then run the generation. It's saying that this promise from this return is not actually being used anywhere, and at least right now it's not because it doesn't really matter. The only thing we needed to do is to create this 3D view and set it to the state. We don't need the return value. And now we can start displaying that visualizer. I'll remove this project name at the top, and I'll bring us back to the visualizer component by heading over to visualizer, and then I'll pick one of the older IDs that we had right here. Looks like the application breaks right now. Let's see why that is. By opening up a console, and it looks like it's just empty. Maybe I can head over to some other visualizer, not the one ending in 661. We can try this 662. No, that one is empty as well. And what about the last one? 6112. This one also is not rendering anything within it. So we don't have any errors, but if you just say test, you should be able to see a test keyword right here, which means that we're good. So let's remove this section right here. And let's instead keep just the div that has a class name of visualizer. And let's indent it properly. And we'll make it display the initial and the updated generation. First, we can add a nav right within it. This nav will have a class name set to top bar, and I'll actually remove this initial image right here since we're starting with this new UI that we're developing. Within this top bar, I'll render a div that's going to display our branding, and I think we already used that within the homepage or within the Navbar component. So within here, we simply want to get access to this box and the span below it that says Roomify. And we can paste it within this div. So this div will have a class name set to brand. And then within it, we're displaying the box with the logo and this span with a class name of name that says Roomify. Then below this div right here, below the brand, we can display a button, our reusable button component. That'll have a variant set to ghost, a size of small, and an on click. It'll actually just handle the back key, so we can go back. And I'll give it a class name of exit, and within it, we can display the X icon coming from Lucid React with a class name of icon, and it'll say exit editor. There we go. So now it'll appear like this is an additional pop-up above the homepage, so we can exit it at any point in time and go back to the homepage. Now we can go below the navigation bar and render another section. This one will have a class name set to content. Within it, it'll have another div with a class name set to panel. Within it, it'll have a panel meta, but this is actually going to be within a panel header. And here we can have a p tag that says project. And all of this together is actually going to be within a div with a class name set to panel. So we have the panel and then within it, the panel header. Because later on, we're going to have the panel actions as well. There we go. So now we have the project. We can render the H2, which for now will render just the fake data about an untitled project, which we can later on fix up. And also a p tag with a class name that's going to say note, and it'll say created by you. And then we can head below this div and render another div for the panel actions, which is going to be still within the panel header. So just give it a class name of panel actions, and within it, display a button that looks something like this. It'll have a size small. We'll leave the on-click empty for now with the class name of export, and it's going to be disabled if we don't have a current image. And then within it, we can display a download icon. And right below it, we can display another button. This one will have a size of small with a share to icon. Also, we'll leave the on-click empty for now because we're going to implement the functionality later on together. And then we display the share text. We can now head 2 divs below this button and that's going to be below the panel header, where we can actually display the images that we have so far. So I'll render a div with a class name set to render-area. And then if it is processing, in that case, we'll render the isProcessing class name, else we won't give it any classes. Then if a current image exists, if that is the case, we will render an image component with a source of current image and an alt tag of AI render and a class name of render-img. But if the current image doesn't exist, we'll need to display some kind of an initial image. So render a div, which we can close, and give it a class name set to render placeholder that's going to check whether we have access to the initial image. And if we do, it'll display an image tag with a source of initial image and an alt tag of original and a class name of render-fallback. So right now you won't be able to see anything because for this project, we haven't yet generated the AI image. And then right below it, below this div and this part where we check for the image, we want to display the isProcessing part. So if we're currently processing this AI image, in that case, we want to render some kind of an overlay. So I'll close this div right here and give it a class name set to render-overlay and another div with a class name of rendering-card and within it a refresh-CCV icon that's going to have a class name set to spinner. Within it, we can render a span that's going to have a class name set to title and it'll say rendering ... And I'll duplicate this span below, change it to subtitle, and it's going to say something like generating your 3D visualization. Perfect. So now we'll need to test everything from the start by heading back over to our homepage and uploading a new floor plan. Now, don't forget that we actually have this generate 3D view function, which will take the old image, it'll take our prompt that we have given to Puter right here, run it against a model that we have chosen, and it'll output the 3D floor plan. So let's give it a shot. I think this deserves us actually opening up the browser on full screen, where for the final time, I will upload this image, and you can see that it is rendering or generating our 3D visualization. So this is amazing, untitled project created by you. We can see the image blurred in the background, and would you take a look at that? This is the final output. Remember, the previous output was just a boring 2D image, but now AI has generated the complete floor plan with furniture, so somebody can go ahead and just buy these furniture pieces and furnish it. We have the bed right here with some closets and 2 nightstands, the kitchen with a stove, a sink, and a fridge, and a whole table right here. Now, it's likely that you already forgot how the initial version looked like, and we're not displaying it anywhere here. But don't worry, because later on we'll implement the before and after view, so you can drag and drop your mouse to see the difference in real time. But with that in mind, believe it or not, that's it. We successfully used an AI model that we fed some text or an image into it, and it gave us the final rendered image. But throughout that process, we have never actually created API keys on Gemini, OpenAI, or any kind of a database or authentication solution. So in this case, Puter is acting as our full-on backend, replacing our authentication provider, the database with their key value storage, the AI providers, and all sorts of different APIs, all within one tool that you didn't have to enter the credit card for, nor you ever will. You just write code and it works, not only for you, but for all the users. Now, if you inspect this image by right-clicking it and opening it in a new tab, you'll notice that it's not an actually deployed URL. It's a data blob, starting with data, text, and then includes a base64 image, which means that if you refresh this page, it's gone. It'll be recreated again. So in the next lesson, we have to host this AI-generated image on the Puter site subdomain and save this project info into the key value database too. We'll do that in the next lesson, but for now, let's go ahead and create a pull request for this new feature we've implemented, generating the 3D design. I think I still stayed in the old branch, which is going to be the branch for hosting images, but that's totally okay. That's technically still what we're working on. We want to host this new image as well. So I'll just run git add dot git commit -m generate 3D design, and then run git push. Now back on GitHub, you'll see that we have recent pull request opened. So let's check it out. And in this one, we use this AI code, so we have to make sure that it is optimized and that it works well. So thankfully, we have CodeRabbit to check it out. Name's Rabbit, CodeRabbit, licensed to review. In this lesson, we finally added a new AI-powered 3D visualization feature. The way it works is the user checks out the visualizer component, the useEffect hook checks it out, and then we generate this 3D view. We do it by talking to Puter.ai.text-to-image, which then returns the AI-generated image, we update it, and we display it to the user. This time, we don't have too many changes. Since we use Juni to generate this, looks like Juni created a tasks.md page, which CodeRabbit suggested not to push over to GitHub, which I agree with. And then there's a little navigation issue right here, but we'll fix this later on as we implement persistent storage within the visualizer. With that in mind, we're good to merge this PR. So let's do just that. And knowing that our code is bug-free, we can continue on to the next feature, which is hosting this AI-generated image on Puter and then saving it into our database. In this lesson, we'll set up Puter.js's serverless workers. They're serverless functions that run JavaScript code in the cloud. You can think of them as a router-based system to handle HTTP requests and then integrate with Puter's cloud services like file storage, key-value databases, and AI APIs. They're perfect for building backend services, REST APIs, webhooks, or data processing pipelines, which is exactly what we're going to use them for. In our case, we're using workers because public data and cross-user lookup need server-side privileges. The client-side SDK can only read and write the current user's private key-value pairs, but the worker runs with a service context, me.puter, to store and fetch public or shared projects for all of the users. So that's exactly what we'll use it for. Back within the code, you can create a new file within lib, and you can call it puter.worker.js. Here, we'll define the worker routes that call Puter KV storage to save the project. So, create a new router.post that can be activated when we go to /API/projects/save. You can think of this as building your own REST API. Then, I'll open up a new async block of code from which we're gonna destructure the request and the response from the params, and then we can open up a new block of code. Within it, I'll open up try and catch block, and in the catch, we can simply take the error and return a JSON error. This is a helper function which I'll create now, and that's gonna be a 500 failed to save project, and we can also pass some additional options, such as message is gonna be error or e.message, or if that doesn't exist, an unknown error, something like this. So now we have to form this error message or JSON message utility function. We can create it right above. Const JSON error is equal to a function that accepts a status, a message, and some extra options like this. Then the only thing it does is it crafts a new response based on the stringified error message. So here we can call json.stringify and pass in the error that's going to be message and spread all the extra properties if there are any. Then we can provide additional options such as the status and the headers, which are going to be a content type of application JSON and access control allow origin, which is going to be set to an asterisk, meaning allow everything. So now we'll be able to reuse this later on when we're creating some errors. We can also create another helper function that's going to make it easier for us to get the user ID. So const get user ID is equal to an asynchronous function that accepts a user Puter, and we can open up a try and catch block. In the catch, we can simply return null if we're unable to find it. But here, we can try to fetch the user by saying await user Puter.auth.getUser. And once we get the user, we can return their ID by getting it from user.uid or null. And now we can use this in this post when we try to save the project. So right here, I'll say const user Puter is equal to user.puter. If we don't have access to it, we can simply return a JSON error. So now I think you can get the idea of why we created it, because we're using it a few times. And it's much easier to provide a status for one and then a message such as authentication failed. But if we got it successfully, we can extract its body by saying await request.json. And then we can get the project out of the body by saying body ?project. And I'm just noticing that this user right here is complaining that it doesn't exist. So this was actually supposed to come through here, request and then user. We're not getting the response here. So that's body and then ?project. Then we can check whether we've gotten it successfully by checking if there is no project ID or if there is no project ?source image. In that case, we can return a JSON error of 400 and saying something like project not found. But if we have the project, if we found its ID successfully, we can form a new payload, which is going to contain all the current information about the project. And we can also append the updated at field, which is going to include a new date. Then we can extract the user ID by using our helper function, getUserID, to which we have to pass the Puter user. And then again, just a sanity check. If we don't have access to a user ID, we can return a 401 error, authentication failed. And it's not Puter user, it's user Puter, how we called it right here. Finally, we can craft the key under which we can store it in the key value database by saying const key is equal to, and we can define the prefix that we can reuse later on right at the top by saying const project prefix is equal to roomify _project _, and then we can add the unique ID. So right under this key, we can make it a template string, start with the project prefix, and then immediately after it, append the project.id to make it unique. Once we have the key, we can set it to the database by saying await user Puter.kv.set. Under this key, set the following payload, which includes the entire project and the updated add field. Finally, we can return it all to the front end by saying saved set to true, ID set to project.id, and project is going to be set to the payload. So this one actually saves the projects or sets the keys, but now think of this as CRUD operations. We also need to be able to get and list all the keys. So we can create additional routes right here, or we can ask Juni to create them for us. So just open up Juni or any other AI agent and tell it to do this. I'll provide you with this prompt in the video kit link down in the description. Just say generate 2 Puter worker router endpoints in lib_puter_worker.js file. The first endpoint should be a GET request for the project's list that accesses user Puter to list all the keys starting with project prefix from the KV store and returns an object containing an array of those values. And the second one should be a GET that extracts an ID from the request search parameters and fetches the specific project from the user Puter KV using the prefix key. Both endpoints need to have proper error handling. So let's press enter and see how well it does it. And we can see in real time how it's, first of all, learning about the code base and then modifying this file in real time. And there we go. That was quick. Now let's go through these and see whether they have been implemented properly. We're first getting the user, then the user ID, and then we're getting that user's projects. We're doing that by saying await user_puter.kv.list with the following project prefix. And then instead of saying values to true, which doesn't exist, we can just set the second parameter to true to make sure that we get the return values into projects. And then we can also map over this data. So we'll wrap this entire await call, and then I'll call the .map on it, where we're going to get each individual value that we're going to destructure. And then for each one of these, we're going to instantly return a new object where we're going to spread the value and set the isPublic property to true. And then we take these projects and simply return them. Now for the second one, where we try to do the .get, I think this part is good. Now you can open up Puter.com to deploy this worker. Simply right-click on the desktop and create a new worker. You can call it roomify.js. Then you can open it up in code and you'll see a new text editor open right within your computer. There are these 3 current routes that just say hello world, but here is where we have to transfer over our worker from the application. So simply copy all 3 of these routes alongside the helper functions and paste them on top of these 3 routes. That way, we'll bring all of the functionalities that we created directly within this Puter worker. Then you can minimize this window, right-click it, and click Publish as Worker. You'll be able to select a name for your worker. So click Publish, and then you'll be given a URL. You can copy it and then head over into it. And there, you'll be able to see Hello World. Believe it or not, you just deployed your own backend API. So once you copy that worker URL, let's move it over in our envs. At the start, I said there's going to be very little envs. I believe there's only one. So create a new file called .env.local. And there say vite_puter_worker_URL and paste this deployed backend URL. In the next lesson, we'll connect these workers with frontend to create, save, or get project information. The next step is to display the data. So right here within lib puter.action.ts, we can collapse some of the functions we have right now, such as create project, and we want to create another one called get projects that allow us to list the projects stored in KV storage via the worker routes. We can do that by exporting and creating a new function called getProjects, which is going to be equal to an asynchronous function. And we can open up the block. First, we want to check if there is no Puter worker URL. And this right here is coming from constants. And basically, it's an import of an environment variable, which we have added in the last lesson right here. You can think of this as our backend. So if it doesn't exist, we'll simply say console.warn, and we'll say missing vite puter worker URL skip history fetch. So we won't be able to fetch any details and we'll return an empty array. But if we have it, we'll open up a try and catch block. You know how we like to do it. In the catch, we can get the error and we can just console.error, fail to get projects for signing in, or we can just say fail to get projects and again return an empty array. But here we can try to fetch all the projects that we've created. We can do that by saying const response is equal to await puter.workers.exec as in execute. And we want to execute the following function within the Puter worker. It's going to be Puter worker URL /API/projects/list. If you remember well, right here within Roomify worker, one of the functions does exactly that. It's going to be the API get API projects list, which is going to return all the projects. So we're simply calling our backend with a method of get. And then when we make this request, we'll get back data in the response. We can make a quick check if response is okay. If the response is not okay, we can run a console.error, failed to, not save project, but fetch history, and then we can display some additional information by saying await response.text like this, and we can just return an empty array. Okay, but if we successfully fetch back the response, from it, we can extract the data, and that's going to be equal to await response.json as, and we can define the type. It's going to be projects, question mark, so optional. It's going to be a list of different design items. That's basically the name for our projects within our application. Each design item contains all the details like the ID, name, source image and path, and then rendered image and path. And finally, we can return array.isArray of data ?projects. If it is an array, we'll return that data projects array, else we'll return an empty array. Now, since we've defined two different routes right here within this worker file, we have to write actions for both to get the list of the projects and also get the project by ID. That is this one right here. Because we'll no longer share project information through location state as we did previously in the home file. Rather, we'll just redirect the user to the visualizer page, get ID from the URL, and then fetch that project info there to display more accurate data. And if you've been paying attention, that's exactly what CodeRabbit pointed to us before, telling us that we need to do it that way. So first, let's head back over into our homepage by heading over to Routes Home, and let's use this new getProjects function to display the results. Right at the top, below the project list, I'll create a new ref called isCreatingProjectRef, and it'll be equal to useRef at the start set to false. Then, under handle upload complete, we can first make a check and see if isCreatingProjectRef.current, then we simply return false because we're currently creating the project. Else, we're going to simply set it to true, so we can then continue with the upload. And we can wrap all of this in a try block, so we can put this entire code that we have here, including the return true, into the try, and then we can also add a finally block at the end. This finally block will simply set the isCreatingProjectRef.current back to false. If you now head back to our application, specifically to the homepage, you'll probably see no projects for now, and that's fine. That's because we have to call the worker to save the project in createProject to save it to the key value store. Doing that is going to be simple. We just have to head over into libputeractions, and under create project, which is right here, we first have to check whether we have access to the Puter worker URL. I think we can search for that, Puter worker URL. There we go. And we need to have this if statement to check whether it exists. That's going to be right here within create. If no Puter worker URL, console warn, it's missing, and return null. Then at the start of the try block, that is right here, call the Puter worker to store project in KV. You can see that here we even left ourselves a note. So what we have to do is call another action from our backend URL. Remember how we called it right here? We called puter.workers.exec, and we're going to do something similar here. So I'll copy this one and paste it here. Const response is await Puter workers exec, and this time we're going to call the project's save, which has a method of post. But alongside the method, we also have to pass some additional information, such as the headers, which are going to be of a content type application JSON. And next to the headers, we also have to pass the body, which is going to be JSON stringified, object that includes the project, which is going to be of a type payload, and the visibility, which is going to be set to public, I believe. So I'll put this right here. And let's check where this visibility is coming from. I think we can get it right here as the second parameter into the create project function, visibility, and by default, it'll be set to private. There we go. So now we have this create project, which is going to call our backend or call our worker. Right below it, we can check if the response is not okay. We can console.error saying something like failed to save the project. And we can also add the await response.text so we know why. And finally, we can return null. But if it saved it correctly, we can extract the data from it by saying data is equal to await response JSON, as it's going to be an object where we're saying that the project is going to be of a type design item or null, not a design item array. We only want to get one project right here, the one that we saved. And finally, instead of returning the payload, we're going to return data ?project, or if that doesn't exist, we'll simply return null. But before trying it out, let's call the create project in the visualizer page as well. The way we're doing it here is we call the create project for the first time that the user uploads the input image. That way, their source or input image is stored in KV, and then when they are redirected to the visualizer page, AI image generates, and we call the create project again to now save the AI generated image, owner, and so on. So for that reason, let's create the get project by ID action within this Puter actions file. That's going to be right here, get projects, and now we can develop get project by ID. This one I'll provide to you within the video kit link down in the description because it's super similar to the ones we have developed so far. We start in the same way. We pass the ID. We check whether the Puter worker URL is missing. If it's not, we simply call another one of our endpoints within our worker and pass in the ID so we can get specific project details. We do some error handling, and finally, we extract the data and return the data for that project, and that is it. Now, finally, we can use all of these, let's call them backend or worker actions within our frontend. So head over into our routes visualizer to call the create project function, or basically updating that project. You can see we even left ourselves a note right here. But to be able to work with that note, we have to create a couple more states and params to be able to track things. First things first, we can extract the ID of the project we're currently checking by using the use params functionality coming from React Router. Then we also need to get the user ID, which we can get by destructuring it coming from use outlet context. And that's going to be of a type auth context, like this. Then we can create a new use state. So I'll use the use state snippet, and that's going to be called a project and set project, which is going to be at the start set to null, and its type will either be a design item or null because it's null at the start. And then finally, we are going to have one for the loading of the project. So use state snippet is project loading, set is project loading, and we're going to set it to true. And in the current image, we will no longer be updating it from the initial render because we want to use the data coming from the backend. So I don't even believe we'll need to use this location state. So I can remove it and remove the location. We'll fetch all the data directly from our backend. So now, right here within this run generation, we no longer have this initial image coming from the state that we're passing from the homepage, but rather we're getting this item of a type design item right through params into this function. So then we can check if we're missing an ID or if we're missing the source image coming directly from the item, in which case we'll return. And then again, we'll generate this 3D view, but we're going to update it in the item.source image. And this item, again, is going to be the one that we're going to pass into this function when we call it. So now, how is that updated item going to look like? We can update it here. Const updated item is equal to an object where we first spread the initial item data, and then we append the rendered image to it. So that's going to be result.rendered image. We also need a rendered path, which is going to be set to a result.rendered path. There's also going to be a timestamp of the update, which is going to be set to date.now. And we also need the owner ID set to item.owner ID or user ID or null if none of these exist. And finally, the is public state which is going to be equal to item.isPublic, or false if it doesn't exist. Then once we get this updated item, we can call our create project action by saying saved is equal to await create project. And finally to it, we can pass an object that includes the item, which is going to be the updated item now containing the rendered image and path, as well as the visibility set to private in this case. Finally, if we have successfully saved that item, we can then set it to the state by saying set project saved, and also update the current image to the rendered image. So saved.rendered image or result.rendered image. We'll also need to use a bit of a use effect to make sure that it all gets properly updated. So we're going to delete this one, and in the video kit link down in the description, I'll provide you with 2 additional use effects, which we're going to add. They're going to ensure that our projects get displayed properly. The first one is adding a variable to check whether the component has mounted. And within it, there's a load project, which sets the project loading to false at the start if it doesn't exist. But if it does, then it starts loading the project and it fetches the current project by ID. This is that function that we created. Don't forget to import it. And then it sets it to the state, it sets the current image, and sets the loading to false. And then we simply call it and unmount. The second use effect is checking whether something goes wrong. So if the project is loading, or if project has no source image, just return. But if everything is good, if it has the rendered image, then we update the image to be the rendered one. That's more or less it. And now back here within JSX, instead of saying untitled project, we can now actually render the project ?name, or if we don't have the name, we can say residence and then render the ID of that specific project. We'll leave this created by you because for now, all the projects are private. And then right here where we have this render placeholder, that's actually going to be coming from project.sourceImage. And we can also pass that source image right here under the source of the image. Great. So now we are ready to test out this entire application by creating a new project. We can do that by heading over here. It's fully empty. So let's go ahead and upload our floor plan. You can see that I'm going to use the one that we had before, which is very empty. And it's going to upload. We get a check mark, and we should have gotten redirected. But if you check the inspect element and head over to console, you'll see that it says failed to create project. If you search your codebase for failed to create project, you'll see that it happens in home line 39, or at least that's for me. That's after we try to call the create project server action, which talks to our Puter worker. This error is most likely coming from our worker file where we try to create it. But let me use Juni to try to figure out exactly where it is coming from. I'll copy this entire error message, paste it over into Juni, and say, can you figure out what I did wrong and where this error is coming from? As simple as that. It'll now get the structure of the Puter action file, Puter worker file, unexpected end of JSON input. Wait, it's actually doing something already? The code was updated right here by removing the incorrect headers and properly formatting the post request body. Interesting. Let's wait for an explanation. Sometimes it's hard to notice the changes based off of this diff. And it continues to get the structure of our other files to see whether the error is also somewhere else or whether this was an isolated case of a mistake in our code. And here's the update. The issue was caused by 2 main problems in the project saving logic. Incorrect API call structure. The body of the request to the Puter worker was incorrectly nested inside of the headers. Oh my God, did it really do that? The body being right here inside of the headers. Oh, that is true. You can see the object starts here and ends here, but now it put it outside, so it's working. And there was also another issue in the Puter worker where it looks like I missed an exclamation mark right here saying if a project ID doesn't exist, but the source ID does. And that's not what we want. We want project ID and source image are both required. So these are great changes. And honestly, nice catch by Juni. Since this was in the worker file, we have to update it within Puter. So I'll copy this projects.save, the one that got modified. That's going to be right here within workers. Copy the workers.save, or I can just copy the entire file since that was the only change. And head back over to Puter, override the current code right here, save it, and then right-click it. And you can see successfully deployed. So automatically, as soon as we saved it, it got deployed. So there's nothing else we have to do, which means that now we should be able to retry creating the project. I'll again upload the same bad looking 2D floor plan. It's going to upload and it redirected. We can see that it is officially rendering, generating our 3D visualization. And it looks like something is happening. And we got it. And for the first time, I believe we're actually saving this as a new project within Roomify. So now if we go back to the homepage by exiting the editor and reloading the homepage, we would expect to see it right here. Let's go to the code to see why that is. If we head over to home, you'll see that here we have the projects, which are initially set to just an empty array. But then when we handle the upload, we navigate to visualization. But nowhere do we actually update the projects. So that part was just missing. We can add it by adding a new use effect that's going to have a single function called getProjects. It's going to be an asynchronous function, and it'll only have one job, and that is to get the items by saying await getProjects. Thankfully, we have already created that function, and then it can simply set it to the state, set projects, items. And then we can call this getProjects function right here. And if it's complaining about the type, you can simply add an exclamation mark right here because we know we're going to get back projects. Also, since this function is called getProjects, it might make sense to call this temporary function fetchProjects. That way we don't have any clashes. And this getProjects has to be imported from getProjects coming from our actions. And if it's the right import, then we no longer need the exclamation mark because it knows exactly what it is returning. So if you now reload on the homepage, you'll be able to see your newly created residence. And we can also head over into that card. So that is under home where we have these projects. There we go. This is the upload card. And right below where we're mapping over the projects, where we have the project card group, we can also add an on click to it, which is going to navigate over to the visualizer ID. So now if you click on it, you'll be able to go to your project details. Wonderful. Now in the next lesson, let's implement that nice visualizer component that allows you to see the before and after as you move your mouse left and right across the image, so you can allow your users to see just how big of an impact your app makes. But just before we do that, in the last few lessons, we've added a lot of code and functionality to our application. So let's go ahead and commit it. Right here within a terminal, you can run git add.getcommit-m, implement Puter workers, creation of the 3D floor plan, and the creation of the project. And you can run git push. Then if you head back over to your GitHub repo, you'll see recent pushes on the same branch, and we can now open up a pull request. 320 lines to review. Let's see what CodeRabbit has to say about it. I see dead code. Okay, let's see just how dead is it. Let's see what we implemented. This PR introduces a backend project management system via a new Puter worker module that provides REST APIs for persisting, listing, and retrieving design projects. The frontend is updated to load those projects on startup, handle project creation with persistence now, and enable navigation between the visualizer and stateful project data. I think we also have some kind of a diagram right here. Yep, in this case, it is multi-part. The top one is the project creation flow, and the bottom one is the project load flow. So from the front end, we create a new project. It goes through the Puter action layer, and then it talks to the Puter worker API. Finally, it touches our database, the key value store, and returns the saved project. Same thing when we want to fetch them. We talk to the actions, we talk to the workers, we read them from the database, and we return them over to the front end. Okay, let's see what CodeRabbit has to say. First of all, there's a major issue. Looks like I accidentally committed the worker URL, which on its own is not that big of a deal, but the env local should definitely not be added to gitignore. So later on, if we add something that should be safe from other people, it definitely should not be put there. So we're given a nice prompt to remove the committed env file from the repository and add .env.local to gitignore. So let's copy this prompt, which was nicely provided over by CodeRabbit, and let's see what Junie can do with it. It's first opening the terminal and seeing which files do we have in there. It looks like it found this env local, and it's going to ask us to remove the .env local from the git cache, add it to gitignore, and then create an env example with this placeholder, which is exactly what we want to do. There we go, gitignore edited, env example added, and we can now run git status and then git push. Perfect. I'll go ahead and commit this, and it'll remove it from the repo for me. Perfect. Let's check the git status right here in the terminal as well, and run git push. Now let's check for the other comments right here. We have a minor one, potential invalid date if timestamp is missing. I believe our timestamp is always going to be there, so this is okay. Misleading warning message in create project. I think this is talking about skipping history fetch, but this is more like you can't create a project if you don't have this env here. So a fix is just to say skipping project save. Sure, you can go ahead and add that. Then the Puter worker, we have a minor issue. Add access control allow origin header to success responses for consistency. It says that our error responses return a response with access control allow origin, but some other lines don't. So for consistency, you can add it there as well. Now there's another one within our worker saying that our project keys are not scoped to the authenticated user. User ID is fetched in line 39, but never incorporated into the storage key, line 42. The key is simply Roomify project ID, so any authenticated user can override any other user's project by guessing or reusing an ID. The same issue exists with list and get endpoints. The proposed fix is to also add the user ID as the key. This is something that I could modify right now, but I'm going to leave it as a challenge for you at the end of the video to implement the private versus public projects, so this can be a part of that challenge for you. This one is also about divisibility, which is going to be about that private and public relationship. And finally, the last one, yes, again, we are hard coding is public to true right now, but later we can use that toggle to shift it between public and private, which means that we are right now good to go. So go ahead and merge it. And in the next lesson, let's implement that visualizer. To implement this visualizer component that's going to allow us to see on left and right both the previous version, the basic plan, and the final version, which is this nice architectural plan, we can install a new package from npm, and it'll be called React Compare Slider. It's a popular package that has about 70,000 weekly downloads that allows you to drag and drop this cursor-like line that reveals some kind of a background, or in this case, it's going to move between two different images. You can use it right here within our visualizer. So it's going to be pages, visualizer. I'll collapse all of the functions right here so it's easier to see. And we want to focus on the JSX part. So head below this panel where we're closing the panel, and right below it, let's render a new div that'll have a class name set to panel and then compare. Within it, we can render a div that'll have a class name set to panel-header, and then within it, another div with a class name of panel-meta, where we can give it a p tag that says comparison, as well as an h3 that says before and after. And then outside of that div, we can render another div that'll have a class name set to hint. And within it, we can say drag to compare. Now, if you go back and scroll below this current project, you'll be able to see the comparison. Below this div, wrapping the panel header, we can create another div with a class name that's going to say compare dash stage. And there we can do the same thing we did before, access the source image and the current image. Only if we have both, then we want to render this React compare slider, which we need to import right here at the top from the package we just installed. This React compare slider will accept a couple of different props. So let's render them one by one. And don't forget that if we don't have access to the previous and current image, we can simply return some kind of a fallback. So it's going to be a div that'll have a class name set to compare dash fallback. And within it, we'll simply render the project dot source image only if it exists. So that's going to be image with a source of project dot source image with an alt tag of before and a class name set to compare dash img. But for this one, the React compare slider, we have to give it a couple more props. So the first prop is going to be the default value, which is going to be 50. So at the start, we'll be able to see 50% of the old image and 50% of the new one. I'll give it the style of width 100%, as well as the height of auto. And then we can choose how the item 1 is going to look like. This item 1 will be a React compare slider image, also coming from React slider. It'll have a source set to project dot source image. Make sure that it is lowercase src, as well as the alt tag of before and a class name of compare dash img, like this. And now we can render the item 2 by copying the item 1, renaming it to item 2, and we'll use the same slider, but instead of the source image, we'll say current image or project dot rendered image, like this. And the alt tag is going to be after, and it's going to say compare image. So now if you go back, we have this big view right here, but below we have this nice visualizer component that allows us to see exactly what we did. This is perfect, but I think I uploaded a very vertical floor plan. So instead, let's go with a horizontal one. I'll search for some very basic floor plan, like let's say this one, or maybe even this one. It's a bit smaller. I'll save it and we'll upload it as well. I'll try to select it. Oh, but it looks like it's WebP, and we're currently only accepting JPEGs. But I see no reason why we wouldn't accept a WebP as well. So I'll see under the accept part, and it is really unacceptable to not accept the .webp in the modern times. So if I add it right here under accepts, so now we should be able to upload it, and we get redirected. It is rendering it. This is nice. I always like to see when AI is doing something that something is actually happening. We can see the final view right here, which soon enough we'll be able to export. But right below it, would you look at that? We can see the side-by-side difference. So let's take a look from right to left. We have this staircase, and then we have this bedroom on top. Pay attention just to the top one. Notice how there was no furniture whatsoever in here. So it figured out that the bed could go here and another bed right there. And take a look at the bottom bedroom. It looks like it decided not to have a bed, but instead it made it an office. A bathroom right here, and then finally a master bedroom. This is a bit of a weird apartment, but I think it handled this one much better, maybe because it already had some 2D elements sketched in. So if you have them, then it's going to be 100% correct and perfect. And while we're here, we might as well add this export button so we can very easily export it. I think this is a perfect task for Juni, so let's open it up. And let's tell it something simple like write a handle export function that downloads the currently rendered image in the browser in the visualizer page. And let's see if this is enough to let it do its work. Again, I always try to write very detailed prompts so both you and I get the same output, but given how good Junie is as implementing things with these very, very short prompts, I don't think that's necessary. You can see this was super simple. It just creates a download link and it downloads it. Let's see if it actually works. If I head back over here, reload and click export, there we go. It opens it up in a new page and we can now just right click it and download it. This is all I wanted. So let's go ahead and commit these changes by running git add dot git commit -m, implement visualizer, and export, and run git push. Then you can head over to GitHub, take a look at the branches, and we have to bring this branch up to date. So we can run git pull origin main -- rebase. There we go, that's it. And now run git add dot git commit -m, implement visualizer, and git push. In this case, we have to do git push -- force. Now, if you get back, you'll see that we'll be ahead of the main, which means that we'll be able to open up a new pull request. So if you head over to PRs and create a new pull request from hosting images over to main, you can see our latest commit, visualizer, and export. It is all here. So we can just go ahead and create this pull request. And then for one last PR for this project, we can let CodeRabbit do its thing. So let's give it a second and let's see what it comes up with. In this PR, we simply implemented the visualizer functionality using the React compare slider dependency. And this was super simple, so we don't have too many fixes. There's only one major one for this export functionality, saying that if current image is a remote HTTPS URL, the download attribute is ignored by browsers. The browsers will instead navigate to the image instead of downloading it. This is totally okay with my end. We've already seen this happen when we tested it. So with that in mind, we can go ahead and merge it to main. Then within your code, you can navigate over to the main branch by running git checkout main, and then run git pull to be able to pull all the latest changes. And then you can test it out, see if all your projects are here, and whether you have the visualizer and the export. It all works, which means that we are now done. I mean, just take a look at what you've built. In this single project, you've engineered a real AI-powered SaaS application. You implemented authentication, first of all, which we haven't really tested recently, so we can do that again by signing in with Puter. You then built a modern React and Vite application, handled drag and drop uploads, converted images to base64, implemented this prompt that turns boring 2D floor plans into photorealistic top-down 3D architectural renders, hosted all of these final files on Puter so they can be publicly accessible by everyone online. You've done that by creating serverless workers, stored and fetched data from the key value storage, and you did it all without managing API keys, without configuring 5 different services. I mean, the only env you have here is for our Puter backend, and you did it without ever entering your credit card details. That's the power of Puter. Everything lives in one ecosystem. AI, hosting, storage, workers, simple, clean, and unified. No infrastructure tax, just engineering. And let's be honest, tools like Junie actually made writing complex logic faster and more enjoyable. I mean, take a look at how many different examples we've used it on. And so was CodeRabbit for catching all of these bugs. That's the kind of AI assistance that actually levels you up as an engineer. So what's next? Well, you can go ahead and build the share or unshare functionality on each one of these projects. You can do it using an AI agent, or you can try implementing it yourself. Let me give you a rough idea of how that's going to work, because you're not here to be in a tutorial hell. You're here to learn. So when a user clicks the share button, you need to remove the project from their private key value storage, move it into the public KV namespace, and then attach their user metadata, such as the username, user ID, and the timestamp. And when they click unshare, you have to remove it from the public KV storage and put it back into their private one. That's it. You already have the building blocks: workers, storage, auth, hosting. You just need to connect the dots. So give it a try and see how it goes. And if you ever get stuck or want to validate your solution, the final codebase is linked below in the description, completely free. But most importantly, be proud of yourself, especially when everyone is scaring you about AI. But AI isn't something to be afraid of. It's something to master. So keep building, keep experimenting, keep breaking things and fixing them, and learn AI not to fall behind. I'll leave the link to the waitlist of the maybe one of our best courses that's going to come out yet down in the description below. It's the ultimate AI development course where we're going to dive deep into agentic engineering. I'll see you in there. Oh, and before I forget, we're still on localhost. So let me teach you how you can deploy this project over on Puter and online in general. Now, before we host this on Puter, I want to make something clear. Since Roomify is just a standard web app that uses Puter.js, you can deploy it anywhere. Vercel, Netlify, GitHub Pages. Puter.js works on any website, so it's not limited just to Puter.com. In fact, deploying to Vercel is as simple as pushing your project to GitHub, going to vercel.com, adding the new project, importing the repo, adding that one environment variable we had, and then hitting deploy. That's it. Your app is live within seconds. But what's cool is that Puter also gives you a free hosting option with your own .puter.site domain, similar to .vercel.app URL. And on top of that, you can publish your app to the Puter App Center, which gives you extra visibility from Puter.com users and even a way to earn money from your projects. So let me show you how to do that. It's super simple. First, within your codebase, head over into React router config.ts. And you have to change SSR to false right here. It's required for the build script to generate the app with the index.html entry point required for deployment on Puter. Once that is done, you can simply run npm run build. This is going to create an optimized production build of your application, and it'll be created right here for you within the build. Then go back to Puter.com. Open up the App Center by heading right here and then clicking the App Center. Click Publish Your App, and they mention here that you can even earn money on Puter. Publish as many apps, they review them, and you will earn money every time your approved apps are opened by users. So let's go ahead and check out hosting right here. You can see all of our instances so far, but under apps, you can create a new app and call it Roomify. It's now being created. While it's being created, go ahead and open up your folder within your Finder or File Explorer by heading to Open in Finder, and by then you'll see your app created. If you want to, you can modify all of the app's details, and then you need to drag and drop the contents of the build client. So that only includes the assets, the favicon, and the index.html. Not the build folder itself, but rather the contents within the client that is within it. And then click deploy. It'll be deployed within a second, so just give it a try, and it'll be opened right here within your computer. We can expand it and see how it looks like, and this is looking great. It feels like a native mobile application. And you can also upload new projects over here. We can go ahead and test it out. I'll go with this one. We are gonna get redirected. Yep, it's rendering. I'm gonna zoom it in, and we'll be able to see the visualization right here as soon as it gets generated. Wonderful. This time it changed the design a bit, which is very interesting. And with that in mind, your app is now available online. So you just have to go to this URL, Roomify2, and whoever you share it with, they'll be able to access it in full screen. Wonderful. With that in mind, thank you so much for watching, and I'll see you in the next one. Have a wonderful day.